Night gathers slowly at the outer edge of the sun's dominion. Photons still fall, but they are thinned by distance and time, sifted through the cold arithmetic of inverse squares until a single mote of dust can almost drink them whole. The ancient breeze that once swelled the heliosphere into a bright, protective bubble arrives here as a weary breath. The heat of the inner worlds is a rumor. The planets are only memories, strung behind like pearls lost on a long road. In this dimness, a small machine keeps going. It carries a clock and a heart of voltage, a tin ear that can hear what emptiness is saying. It is not sailing for glory. It moves with the patience of geology. It moves because the sun pushed it, and because gravity keeps its promise. There is a boundary here, although no lines are drawn. The atoms are colder, the plasma is denser, and the magnetic field runs like a hidden grain through the wood of the galaxy. Inside the boundary, the wind belongs to the star that raised the worlds. Outside, the wind belongs to everyone else. The small machine feels this change before any eye could. It counts particles like a lighthouse counts waves. It waits for a tone to rise in the wires, a low hum born when disturbed electrons ring like a crystal bowl. It tastes the field with a magnetometer that is little more than a metal sense of touch. Every tick of its instruments is a syllable. Every syllable adds to a sentence humanity has never heard. He is not a hero and not a creature. He does not dream. Yet he carries the sky of a planet carved on a gold foil memory. He carries the thunder of greetings and the hush of a child's breath. By the time he reaches the borderland, the tape recorders have aged, the power has faded, and the team that listens on Earth has grown older with him. They lean close to their antennas like people around a fire, waiting for sparks to break free. Distant storms from the sun peel outward, thin shock fronts that travel for years. They arrive as gentle knocks. The knocks make the local plasma sing, and the song betrays its density. The machine writes down the music with wires, and the wires speak with a voice that can cross the gulf. Between the sun and the galaxy lies a contested shore. It is not warlike. It is not still. It is a place where pressure balances pressure, where the outward flow is met by the inward rain of cosmic rays that wander like pilgrims from supernovae and remnants older than the continents. The small machine moves into that shore, as a wader steps from sand to deeper water. The temperature does not rise, yet the feel of motion changes. Charged particles that once fled outward with the wind are turned back. Others arrive from the dark with more vigor than before. The instrument that counts them begins to revise its expectation of normal. There is silence here that is not empty. It is the silence of a concert hall before the first bow touches the string. It is the silence of a cave mouth at dawn. The machine hears a faint, low-frequency murmur and knows that space itself is not truly a vacuum. It is a sea of ions and electrons, rarefied yet real, capable of carrying sound in a register too low for human ears. When the sun coughs, that cough crosses the light years inside the solar bubble, then reaches this shore and gives the local sea a shiver. The shiver tells a story about how tightly the particles hold each other, about where the sun's breath ends and the galaxy's breath begins. He keeps no map, only a ledger of changes. The direction of the magnetic field eases, but will not swing to a new compass. The particles from the sun weaken, and the cosmic rays from the vast dark strengthen. The star's wind slows, as if stepping behind a curtain. The density of the plasma beyond the curtain rises unexpectedly, as if the small machine has pushed his head through a thin skin into colder water. The numbers that return to Earth are not poetry, yet they begin to feel like it. They speak of a membrane, of a place that is a threshold rather than a wall. Beyond it lies a medium that has wandered for millions of years, threaded by the memory of the galaxy's larger magnetic architecture. That medium is not calm. It is crosshatched by turbulence at scales that would dwarf any world. It carries relics of ancient detonations, the ash of stars, the slow drift of hydrogen shaped by fields no one can see with eyes. The small machine cannot look around. It can only look local, and local is enough. The count of high-energy particles rises and holds. The plasma tones return higher than before. The wind from the sun is thin, nearly gone. The change is not a flourish, it is a verdict. The sun still shines, and its light still reaches. but its influence on motion has failed. The machine feels that failure like a sailor finding the end of a river where it meets the sea. The current no longer helps. The river mouth opens into tides set by other moons and other winds. The little craft is still moving, but its allegiance has shifted. It is not a citizen of the planets anymore. It is a witness for the galaxy, a guest who has crossed a threshold that no living eye will cross for a long time. Its antennas are the only bridge between the household warmth of the inner system and the indifferent weather outside. The questions that bloom here are simple and huge. What does the space between stars feel like? How dense is it? How do fields arrange themselves when star winds push and the wider medium resists? How do cosmic rays find their path and their patience? What is the true shape of the sun's influence? Does it trail a tail like a comet, or fold into a croissant of pressure and field, or does it settle into a drum, faced into the oncoming flow? The machine cannot answer in pictures. It responds in a grammar of rises and falls, with spikes like lightning and plateaus like plains. Each number is a grain of sand poured onto a scale, and as the pile grows, a pattern takes on weight. Inside the receivers on Earth, the voices of machines become a single murmur that spans decades. The small craft is only one voice, but it is the one that has left home. It pronounces the boundary at last. It lists the signs. Solar particles fall. Galactic particles climb. Plasma density jumps. Magnetic direction steadies, as if guided by larger hands. None of these are absolute alone. Together they are a chord, and the chord sounds like a door opening into a wider room. The room is not empty. It is filled with distance. It is filled with an invisible weather that beats slowly, like the swell of a deep ocean. The craft listens. The craft reports. In the thin light beyond the planets, ashes of sunlight drift past its instruments, relic photons from a star it still recognizes but no longer obeys. The craft does not know that it is the first envoy to return with news from this shore. It does not know that its quiet confirmations are the most radical kind. The idea that the star's kingdom ends has shifted from story to measurement, from hunch to record. If a boundary can be crossed, then leaving is real. If leaving is real, then the space between stars is no longer a myth but a landscape. The machine has not solved that landscape. It has whispered that it exists and that it has character, that it can be described by density, by field, by the flux of particles that fall like rain. There is meaning in that rain. It speaks of origins and travel, of ancient fires and the pathways that carry their embers. It speaks of pressure meeting pressure, of the balance that defines the shape of a bubble cradled in a larger flow. It speaks of a place where the sun's voice is quiet, and the galaxy's voice, long and low, becomes the new ground tone. He was born of graphite epoxy, aluminum honeycomb, and patient minds working graveyard shifts beneath fluorescent skies. In Pasadena, the Jet Propulsion Laboratory collected 1,000 human intentions and soldered them into a single will. The year was 1977 by the time both craft stood ready. At Cape Canaveral, white towers framed two slim Titans with Centaur upper stages. The first to fly was the one named Voyager 2 on August 20. The second was Voyager 1 on September 5, drawn onto a faster path that would overtake its twin. Their destination was not a place pinned on a wall map. Their destination was a sequence of chances that only happens once in a lifetime, an alignment of giants that would let a small machine borrow gravity and keep going. He carried a 3.7-meter dish like a shield, polished to focus whispers across a widening void. Behind the dish, a body no larger than a small car held computers with memory measured in kilobytes and a pair of tape recorders that would spend decades catching and releasing the breath of deep space. 3 radioisotope thermoelectric generators glowed a gentle red on a boom, turning the slow heat of plutonium into electricity. At launch, the power could warm a household bulb into a modest Sunday. Every year the light would fade by a fraction, and still the circuits would keep their watch. He travelled with a crate of senses. A magnetometer perched on a long boom to keep the spacecraft's own fields at arm's length. 2 instruments counted energetic particles over a wide range of energies, listening for the rain of ions and the sudden rise of high-energy cosmic rays. A plasma science instrument measured the flow of charged gas streaming from the sun, though on one craft that instrument would fall silent after Saturn, leaving other ears to take up the role. A plasma wave system carried two long antennas like silver reeds. Those reeds would let space itself play as a low violin, humming at frequencies that betray the density of electrons around the craft. Redundancy was not a luxury. Redundancy was survival, because all of it would have to work far from any human hand. He had company on the ground. The Deep Space Network spread 3 listening posts around Earth in California, Spain, and Australia, each with dishes like white lilies turned to the dark. As the planet spins, one station passes the signal to the next, so that the thread from the craft to home does not break. The signals are weak enough to be drowned by a kitchen appliance. They are also sharp enough to carry a living physics experiment. Engineers learned to pull meaning from the noise the way a tracker reads wind in grass. Doppler shifts of a few parts in a trillion-measure motion. Small phase differences reveal tiny twists in the magnetic field. The larger machines on the ground became partners, as vital to discovery as any sensor in space. He sailed a path that transformed the possible. Gravity assists around Jupiter and Saturn taught the probes to trade momentum with the giants. Voyager 1 curved above the plane of the solar system after Saturn. Voyager 2 kept faith with the original ambition, visiting Uranus in 1986 and Neptune in 1989 before slanting outbound into southern sky. Those visits made headlines and filled memory with storms and rings and moons that had never been seen so close. Yet the architects had already given the craft a second purpose. Beyond the show of planets, they were meant to become field stations in the outer wilderness, to keep counting, to keep listening, to treat distance as data. He carried a gold record packed with music and greetings and thunder. It was a kindness placed there by dreamers who understood that the void could be a library. The record did not measure plasma or magnetism, but it said something about the makers that no instrument could say. For the scientists who would read the telemetry, the essential language remained numbers. They waited for signs that the star wind, which spreads outward like a river, would thin and give way to a different current. The first hints would be a fall in the count of particles born near the Sun and a rise in the count of cosmic rays that wander the galaxy. The second hint would be a change in the pitch of the plasma waves when a distant solar shock rolled by and set local electrons ringing. These were not glamorous clues. They were as plain as rainfall in a bucket, and as meaningful. He had a guide among humans, a physicist named Edward Stone, who became the calm interpreter for generations of listeners. Teams from universities and laboratories tended each instrument like a garden. They learned the habits of the craft and the quirks of the data stream. They wrote command loads that arrived after hours of travel and took effect with the grace of a handshake. They watched power margins shrink and adjusted heaters and voltages with a discipline that would be mundane if the stakes were not the oldest questions in astronomy. What happens to a star's breath at the limit of its reach? What waits beyond that limit? The discovery would belong to the patience of people as much as to the hardware that represented them. He faced problems with quiet stubbornness. The camera shutters were powered down to save energy once the portraits were complete. The scan platforms creaked and aged. The cold made lubricants slow. The sun grew more distant, and radio round trips stretched until a single question took a full day to ask and answer. In that regime, foresight is the only speed. Engineers rehearsed each switch and mode change in simulators on Earth. They practiced the path of a command through memory and into action. They sent it when the stars and the schedule aligned, and then they listened. The work felt like winter farming in a land that sees one harvest every many months. He drew near a place with no lines, and yet a difference that instruments could mark. On the 25th of August 2012, readings from one craft showed a lasting drop in solar energetic particles and a sustained increase in the highest energy cosmic rays. The plasma wave instrument heard a set of tones later that year, triggered by a solar outburst that had taken more than a year to reach that far frontier. The frequency of those tones matched the electron density expected for local interstellar space, rather than the rarefied interior of the Sun's bubble. The boundary had a name, the heliopause. The crossing had a date and a distance, about 121 astronomical units from the Sun, a number built from radio milliseconds and counts on a detector. He did not travel alone for long. On the 5th of November 2018, The twin crossed a similar threshold in a different quadrant, at about 119 astronomical units. The instruments reported the same kind of particle exchange and a new plasma density revealed by fresh, resonant tones. Two independent arrivals broke the spell of a single case. Discovery hardened into a map with 2 points and a hint of shape. The craft did not shout, yet the message was heard in classrooms and observatories. The sun lives within a membrane of its own making. Outside that membrane, the medium is denser and more ancient, and its magnetic discipline carries a pattern laid down by larger galactic forces. He was handmade in an era of slide rules and early code, but the design contained a future inside it. Pointable high-gain antennas, distributed booms to reduce interference, multiple particle counters covering overlapping ranges, a plasma wave system that needs only a tone to find density, even when the direct flow meter falls silent, a power source that cares nothing for distance from light, a radio link that can be tuned and refined by ever larger dishes on Earth. Each choice added resilience to the quest and turned a set of planetary tourists into ambassadors, able to testify about a place no human will see with eyes for a long time. He is still talking. The voltages are lower. The edges of the budget are sharp. Memory ages. Yet the craft remains a witness built by careful hands. The discovery it delivered was not a thunderclap. It was a patient gathering of evidence, a gradual brightening of a picture drawn in counts, tones, and field angles. It said that beyond the reach of a single star, space holds its own weather. It said that a machine with good ears and honest clocks can learn that weather, one quiet hour at a time. It said that humans can build a thing that travels beyond their own sphere of storms and keeps its promise to report what it finds. The shock arrived quietly, as numbers that refused to behave. Models had traced graceful gradients in the far outskirts of the sun's influence, predicting a long, soft fade where the solar wind would thin and warm, where fields would twist and relax, where cosmic rays would leak inward with reluctance. The equations did not imagine a cliff. Then the instruments tallied a set of abrupt turnings that looked less like weather and more like a threshold, a step up in one column, a step down in another, held steady with the poise of a verdict. The surprise did not shout. It sat in the telemetry like a change of season that happened in an hour. The solar wind, measured for decades as an outward rush of charged particles, had always seemed ubiquitous. Even at the outer planets, it arrived as a persistent breath. Theory allowed that the stream would pass a termination shock and slump into a slower, hotter sheath. It should continue outward as a dawdling flow, still solar in origin, still pushing, however gently. Instead, the count of solar energetic particles fell like a stone, not briefly, not as a passing lull, but as a lasting absence. The outward population that had been the background of the entire mission simply dwindled to near silence. A wind long considered the default setting of local space became a memory. If the star's particles fell, something else rose. High-energy cosmic rays, born far from the sun in supernova remnants and other violent furnaces, pressed inward and climbed to new steady levels. The rise was not a noisy storm. It was a firm elevation across energies, the signature of a different reservoir, claiming the terrain. Transport theory had suggested a slow modulation, a gentle war between outward wind and inward wanderers. The data revealed a handover that was almost surgical, as if a membrane had been crossed, and two reservoirs had swapped dominion across a razor edge. Density supplied the most startling figure. Electron plasma tones, the low radio hum set off when distant solar shocks reach the region and shake local electrons, shifted upward to frequencies that implied an ambient density far higher than expected inside the sun's bubble. The values matched what had been forecast for the interstellar medium, not the heliosheath. This was not a vague impression. It was a measurement anchored in the physics of oscillating electrons. Where a rarefied interior had been assumed, a thicker external sea announced itself with a clear, ringing note. Space had not become warmer, but it had become heavier, in the way that water feels heavier than air. Magnetism added a riddle inside the shock. The direction of the magnetic field did not swing to a wholly new compass. Prior expectations had prepared minds for a pivot, a strong rotation from the Parker spiral that curls outward from the Sun to a galactic field with a distinct orientation. Instead, the field strength rose while the direction shifted only modestly, as if the external medium and the internal spiral were entangled, or as if the boundary encouraged alignment over turmoil. A boundary that allowed particle regimes to switch so decisively, yet asked the field to keep its manners, did not match the simplest pictures of a wrinkled, turbulent frontier. Temperature teased another contradiction. Hydrodynamic expectations had pictured a sheath where much of the kinetic energy of the wind would become heat, inflating the region into a hot, pressurized buffer. Observations told of a cooler sheath and a crisper border. The energy seemed to have gone missing, not stored locally as warmth but carried away by forms not yet fully named. Possibilities marched in. Pickup ions with outsized roles, neutral atoms that slip between charges and siphon energy, reconnection channels that smuggle momentum across the frontier. Each suggestion accepted that the earlier bookkeeping had overlooked an export. Sharpness itself became a challenge to habit. Space boundaries often present as zones, not switchbacks. Planetary magnetopauses and bow shocks have widths, ripples, asymmetries, hysteresis. What unfolded here looked astonishingly thin. Particle intensities jumped within spans that, given the craft's speed, implied a layer no wider than a few tenths of an astronomical unit, perhaps much less. The notion that a 1,000,000-kilometer thick skin could police a star's climate from the galaxy's climate with such authority asked for a revision of how pressure, charge exchange, and magnetic draping cooperate on the largest accessible scales. Time entered the shock as an accomplice to surprise. The boundary did not merely pass under the instruments and recede. It held its character over weeks and months despite the Sun's moods, and the arrival of new shock fronts riding outward from coronal eruptions. There were wiggles, yes, and pulses that revealed fresh details, but the overall state did not slither back into ambiguity. Expectation had leaned toward a noisy, variable perimeter that would smear identity. Observation kept pointing to a stable partition that endured like a coastline instead of a foam line. Anisotropy, the directional bias of incoming cosmic rays, also shifted in ways that cut against comfortable forecasts. Inside the Sun's reach, particles had been guided by the spiral field, their motions shaped by scattering centers that favored certain paths. At the threshold, the patterns altered, as if the external medium offered a different lattice for travel. The change hinted that the galaxy's magnetic discipline in this locale is more orderly than the textbooks had granted, or that the turbulent spectrum outside skews to scales that favor a narrower set of avenues. Either way, the gradient and the guiding hand did not resemble the softened border that had been sketched at conferences. Wave behavior contributed its own unease. Low-frequency plasma waves sang louder and higher outside, reflecting the denser sea, yet their coherence over long stretches showed less of the jagged interference expected in a bruised, turbulent curtain. If a froth of eddies and reconnection islands had dominated, the wave trains would have scattered and smeared. The signals arrived with a legibility that felt almost marine, as if the craft had left a river bar and entered deep water where long swells roll with an even period. Even the very idea of what marks a boundary came up for review. Is a frontier defined by the behavior of particles, by the orientation and strength of magnetic fields, by the density of charge carriers, by the cessation of bulk outward flow, or by a combination weighted towards some privileged quantity? The evidence forced a composite answer in which particle populations provide the most decisive switch, density the most diagnostic number, and magnetism the most stubborn holdover. The frontier could not be framed as a single surface of simple physics. It behaved like a negotiated truce line, held taut by several forces that rarely agree. Scale humbled confidence. A single craft reported from one point, and later a twin offered a second point, far away, in direction, but not in principle. Each crossing happened at a slightly different distance, separated by years and by solar activity states. The similarities between the events strengthened the case for a real physical membrane. The differences in distance and detail pressed the need to see the frontier not as a perfect sphere, but as a living shape that puckers and flexes under external pressure from the local interstellar cloud and internal pressure from stars' variable wind. The shock to expectation was not only about numbers, it was about narrative. The community had told itself a story in which the sun fades gently into the galaxy, a long handshake slowly letting go. The craft forced a rewrite in which the handshake ends and a door begins, where the temperature ledger fails to balance unless new carriers are admitted, where the field keeps its angle as a courtesy, while particles change citizenship in a single stride. The new story is stricter and stranger, with sharper edges and a cooler tone. Nothing here violates physics. Everything here violates habit. The equations permit thin layers, magnetically draped skins, charge exchange that drains heat, transport regimes that change over distances too small to comfort intuition. The instruments did not break the rules. They invited the rules to speak plainly in a language that had not been heard at this scale. The surprise lay in being confronted by a border that is both delicate and decisive, an unseen skin that can be crossed in an afternoon by a small machine, and still divide two climates of space with authority. That is why the data felt like a jolt. It condensed decades of prediction into a set of crisp transitions that refused to fuzz out. It asked questions that turn with fresh teeth. What mechanism protects the magnetic direction from a sudden pivot while permitting particle populations to exchange so firmly? Where did the expected heat go? And how widely does that export operate among other stellar bubbles? How thin can a cosmic membrane be and still hold back a wind measured in astronomical units? The shock was never a single spike on a plot. It was the realization that a star's edge can behave like a true edge, and that the wider sea beyond has a personality ready to be described, not assumed. Evidence accumulated in small, disciplined increments. Each increment looked modest by itself. Together they formed a contour that traced the character of the region with patient clarity. The plasma wave system spoke first in a way no other instrument could. When a solar disturbance reached the frontier, it stirred the local electrons and set off a ring at the electron plasma frequency. The tone arrived as a simple pitch. From that pitch, the density of the surrounding electrons could be read like a thermometer. The earliest tones outside the sun's bubble pointed to a density close to 1/10 of a particle per cubic centimeter. Later tones climbed even higher. The trend did not suggest a temporary pocket. It looked like a slope, a gradual increase with distance that hinted at a pressure gathering in the local interstellar medium. Magnetic readings laid down a second thread. The field strength strengthened, compared to interior values, while the direction shifted only modestly. Small ripples came and went, yet the overall orientation held with an almost stubborn continuity. That combination contradicted the easy picture of a chaotic fringe. The numbers preferred a boundary where the external field draped and pressed, rather than tumbled and tangled. At intervals, the craft crossed sector-like changes in orientation that reminded the teams of folded sheets more than shredded cloth. The field seemed to slide along the membrane, as if respecting a larger architecture that refused to break. Energetic particle data filled in the weather of space with a precision that surprised even the long watchers. High-energy cosmic rays settled into a stable plateau significantly above interior levels. The rise held across different energies, yet the increase was not identical for all. The spectra bent in a way that revealed transport properties of the surrounding medium. Particles of different rigidity diffused with different ease, testifying to the scale and strength of turbulence outside. In the same data, occasional temporary dips appeared that moved past like shadows. Those dips were not storms from within. They appeared to be structures drifting through the medium, possibly magnetic folds or regions of enhanced scattering that blocked certain paths for a time before the counts recovered. Anisotropy offered another clue. The arrival directions of particles shifted, exposing a guiding lattice that differed from the familiar spiral within the sun's realm. The pitch angle distributions tilted toward patterns consistent with a smoother, more ordered field environment. The inference was unsettling and satisfying at once. Outside, the magnetic scaffolding seemed less tangled than feared, at least at the scales that influence high-energy travelers. That relative order helped explain the sharp exchange of particle dominion at the frontier. A tidy outside lets differences persist rather than blur. Temporal markers became the surveyor's stakes. Shock fronts launched by eruptions on the star moved outward for more than a year before their signatures reached the listening posts in the dark. Each arrival produced a clear tone in the plasma wave system and a temporary rearrangement in magnetic and particle readings. The sequence of such arrivals mapped density changes like sonar profiles. The calculations showed a consistent rise in electron density with continuing distance, a rise steeper than simple models had predicted. The interstellar sea appeared not only denser than the heliosheath, but also structured on scales of fractions of an astronomical unit to several astronomical units, with pockets and gradients that echoed an old, turbulent history. Radio science added refinement through Doppler tags at almost unbelievable precision. Minute changes in frequency from the spacecraft carrier exposed subtle accelerations and pressure nudges at the frontier. Although the craft moved on ballistic arcs, their radio heartbeat reported the slightest pushes from the surrounding medium. The pushes were small enough to be almost poetic, yet they were measurable. The outer plasma pressed more firmly than the inner wind had done in the fading heliosheath, and that pressure helped set the scene for a compact, decisive boundary. Comparisons between the two outbound trajectories strengthened the case for a shaped frontier rather than a symmetric shell. One craft met the membrane at a greater distance during a quieter solar epoch. The other crossed closer during a more active time. Both reported the same essential markers. Both recorded higher plasma density outside, stronger magnetic field, and a rise in cosmic rays. The difference in crossing distances hinted at an external pressure that is not uniform. The local interstellar cloud appears to squeeze the bubble more in some directions than in others, sculpting an asymmetry that only widely spaced witnesses could reveal. Small bursts in the plasma wave instrument recorded a local texture that might be called weather. Short-lived whistles lined up with the arrival of interplanetary shocks, but some appeared without clear triggers from the star, suggesting that interstellar turbulence rattled the local electrons on its own. The repetition rate, intensity, and decay of these tones offered a way to estimate how energy moves through the medium. Damping time spoke to collision frequencies. Line shapes spoke to temperature. The music of that environment began to sound like a score that could be read for parameters, not just marveled at for novelty. There was also the matter of charge exchange. At the boundary, neutral atoms from outside can wander inward and become ions when they meet solar wind protons, while ions from the sun can steal electrons from neutrals and depart as fast neutral atoms. The bookkeeping of those trades implied a way to drain energy from the heliosheath without leaving the expected heat behind. The particle counters, magnetometer and density readings, when combined, left little room for a hot, swollen sheath. The heat had been transported away in more subtle forms. These exchanges likely contributed to the thinner-than-expected layer and the calm field behavior that persisted just beyond. Another finding grew quietly inside the cosmic ray data. Variations in the ratio of different elements and in the abundance of secondary particles shed light on how much material those rays had traversed before arrival. The numbers suggested path lengths and scattering histories that matched an environment with intermediate turbulence. Not glassy like a crystal, not chaotic like a storm. The balance favored long, coherent drift, combined with selective scattering centers that leave fingerprints in composition. These subtle patterns inform models of how similar bubbles around other stars might admit or exclude cosmic rays, with consequences for the chemistry of clouds and the atmospheres of worlds that circle inside. Distance kept turning into knowledge. The outbound speed, on the order of tens of kilometers per second, converted temporal changes into spatial scales. A day of steadiness meant a span the size of the Earth-Moon gap. A week meant a slice wider than the orbit of Mercury. Months carried the craft through regions comparable to the thickness of the heliopause itself. By tallying how long a feature lasted in the stream of data, the teams could sketch the size of structures without any camera. A long, smooth plateau in magnetic strength marked a broad, draped region. A quick spike defined a narrow fold. A ladder of repeated tones revealed layered density steps, like terraces down a submerged slope. The long carrier signal from the spacecraft also participated as a probe of the environment. Scintillation effects, tiny twinklings imposed by plasma irregularities, added a high-frequency grain to the radio tone. By studying that grain, scientists inferred the spectrum of small-scale turbulence along the line of sight. The results complemented the in-situ measures, bridging scales from the size of the spacecraft to the long scales set by the interstellar cloud. No single instrument could cross that span. The combined interpretations made it possible. The deeper investigation did not end in a grand portrait. It assembled a set of disciplined portraits of local truth. The outside is denser than the inside, and the density keeps rising with distance. The magnetic field is stronger and surprisingly well behaved in orientation, suggesting draping rather than chaos. High-energy cosmic rays find an easier path and settle into a new equilibrium that reveals the scale of turbulence. Structures drift by that briefly distort counts and tones, carrying the signature of a medium with memory. Energy that once was expected to warm the sheath has been exported by exchange processes and possibly by thin corridors that link fields across the boundary. The frontier itself is narrow, shaped by pressure from a non-uniform interstellar cloud and held in line by a field that prefers continuity to fracture. These are not decorations on a map. They are the map. They describe a place where pressure, magnetism, and sparse matter reach accord on scales that dwarf worlds. The craft carries that accord in slow telemetry that crosses the dark as faithfully as a lighthouse beam. Each increment of data deepens the outline. Each tone, each count, each angle gives the region more depth, more texture, more truth than the old sketches could grant. It is a cartography of invisibles, assembled by a machine that keeps time, listens closely, and accepts the patience required by a frontier that reveals itself in whispers. Patterns should have converged with time, yet time opened more doors than it closed. The frontier yielded sharp transitions in particles and density, then refused to grant a matching turn in magnetic direction. Field lines strengthened, but stayed close to the old orientation, a stubborn loyalty that asked for an agent of discipline. Draping could explain part of it, with the external field sliding over the bubble like cloth over a sphere, yet this picture left unanswered why particles behaved as if a gate had snapped shut, while the compass needle barely nudged. The mismatch turned a tidy boundary into a riddle that deepened with every quiet hour of measurement. Heat seemed missing from the books. The heliosheath ought to have been a wide, hot buffer where the wind's kinetic energy converted to temperature. Instead, the ledger came back cool. Pressure existed, density rose, but expected thermal signatures lagged behind. Charge exchange with neutral atoms offered a thief that steals energy without noise, creating fast neutrals that slip away unseen while ions slow and the sheath thins. That explanation carried weight, yet the sums did not settle completely. If so much energy had left by quiet trades, why did traces of turbulence appear calm on the outside? And where exactly did those fast neutrals dump their borrowed momentum? The question multiplied into a network of smaller puzzles, each asking for a cleaner trail of evidence than the sparse instruments could draw. Thickness became another tease. The transition layer looked narrow, sometimes so thin that the craft crossed it in less than a day. Boundaries in space usually sprawl. Planetary magnetopauses ripple and breathe. Bow shocks wobble and reform. Here the switch behaved like a membrane under tension, uniform over spans that dwarfed the instrument booms, yet capable of holding a crisp line. A membrane that thin should be vulnerable to tearing by reconnection. The magnetic process that stitches and unstitches field lines and opens tunnels for plasma to flow. Evidence of such tunnels appeared in hints, small changes in particle anisotropy and brief dips in counts, but not in the riot one might expect if tearing dominated the scene. The frontier acted porous and firm at once, a paradox that resisted simple physics sketches. Distance complicated every inference. Two paths crossed the border in different hemispheres and at different times within the star's cycle. Each delivered its own numbers and tones, consistent in the broad strokes, deviant in details. One crossing occurred closer to the star than many models had proposed, despite a more active epoch that should have swollen the bubble. The other came farther than a conservative estimate would allow, yet the basic signatures matched. The conclusion was obvious and unsatisfying. Shape matters in ways not fully captured, and the local interstellar cloud squeezes harder from some directions than others. Without more trajectories, each added datum only sharpened the silhouette of ignorance. Cosmic rays deepened the unease. Outside, their count rose to a plateau, but the spectrum bent, and the directional patterns shifted in ways that announced a transport regime unlike the inner spiral. The turbulence data pointed to a Goldilocks state, not glassy, not chaotic, capable of steering high-energy travelers along preferred corridors. If the field is more ordered, Why did the boundary not force a clear rotation? If the field is less ordered, why do arrival directions keep the neat signatures of guide rails? The interplay of turbulence scale, particle rigidity, and slow drift wrote equations that easily filled chalkboards and rarely fit on a single plot. Every attempt to reconcile the signals forced the models to pick which contradiction to honor. Radio tones that reveal electron density also carried a disquieting lesson about silence. Those tones require a shove, typically a shock born at the star and stretched thin by distance until it reaches the frontier. The tone is loud when the shove arrives, then the room grows quiet again. Between these moments, density must be inferred by less direct techniques, or not at all. Gaps in the record opened room for arguments. Is the density rising monotonically with distance, or is it climbing in steps, or does it flex with the pulse of faraway clouds and fields? Each interpretation could claim a slice of evidence. None could claim the whole. Magnetic sector crossings added texture and confusion. Folded sheets, stacked like lasagna, drifted across the craft. Some carried a whiff of the inner spiral, others felt new. Were these relics pressed flat against the outside of the bubble, or fresh structures formed by draping and shear? A fold might masquerade as a rotation, and a rotation might look like a fold, depending on the craft's path through a three-dimensional maze. The instrument sees only a line. The reality is a volume. Trying to rebuild a volume from a line is an art haunted by ambiguity, especially when the line changes direction only because the craft spins to keep its antenna on target. Even the shape of the entire bubble refused to behave like a familiar object. A long comet tail would align with downwind flow in the interstellar medium. A wide drum would face the oncoming wind with a blunt prow. A croissant would pinch at the flanks where magnetic tension gathers. Each shape solved some inconsistencies and created others. A thin boundary fits a draped prow and a pinched flank. A stable magnetic direction fits a wide, disciplined exterior field. Charge exchange fits anemic heat and brisk energy export. Yet when these elements are combined, small contradictions crop up in corner cases, and the picture blurs again. The frontier seemed to argue that nature prefers hybrids, not single metaphors. The bow region ahead of the bubble carried its own uncertainty. Is there a true bow shock where the interstellar flow crosses from supersonic to subsonic, or is there only a softer bow wave where the flow mutters but does not break? The answer depends on the temperature and density of the surrounding cloud, and on the speed of the local flow. Numbers for those properties carry wide error bars. A true shock would send clear signatures downstream. A wave would whisper. The instruments near the boundary did not present a decisive verdict, and they may never do so from their vantage. That ignorance leaks backward into every attempt to map forces and shapes at the edge. Energetic neutral atom images from near Earth added tension in the form of a bright ribbon across the sky, a band that lights up where theory had not placed a beacon. The ribbon's location lined up better with regions where magnetic fields run perpendicular to the line of sight. That inference suggested a global scaffold of field direction that the craft's local readings only partly echoed. Does the ribbon trace a global drape, or a local lensing effect created by charge exchange, or a resonance in the ballet of ions and neutrals? Each option harmonizes with some data and grates against others, and the frontier remains a stage where all three might play at once. Noise in the data was not always an enemy. Sometimes it arrived as scintillation and tiny twinkles in the radio link that mapped small-scale turbulence like frost patterns on glass. Yet even here, interpretation demanded careful subtraction of the interplanetary contributions closer to home, and the subtraction relied on models that the frontier itself had already unsettled. The deeper the attempt to isolate the outside, the more the inside raised its hand and asked to be accounted for with new precision. Progress became possible only through iterative humility, a willingness to let each apparent fix reopen earlier assumptions. The mystery deepened, because each confirmable fact seemed paired with a reluctance to generalize. Density rose, but the gradient breathed. Particles swapped regimes, yet their guiding field kept a familiar face. Heat drained away, while the calm beyond looked too orderly for the amount of reconnection that the missing energy would suggest. The layer stayed thin, while porosity hints appeared like pinholes in a drum's skin. The large-scale shape needed a name, while every proposed name threw shadows onto some graph that refused to cooperate. The frontier did not behave like a single phenomenon with a single cause. It behaved like a treaty negotiated by processes that do not share a language, each speaking through its own instrument, each correct within its narrow right, each unable to claim the whole truth. In that complexity lay the growing pull of the question. The boundary proved real, strong, and thin. The outside proved denser, older, and more ordered than many had guessed. Yet the manner of the separation and the mechanisms that uphold it turned out to be a richer puzzle than the existence of the border itself. The more clearly the instruments spoke, the more eloquently they reminded their listeners that the edge of a star is not an edge in a simple sense. It is a living contact between a wind that remembers its birth and a medium that remembers the deaths of other suns. A contact that edits both memories in real time and that resists any story that tries to be single and final. Explanations gather like constellations. Each star of thought offers a point of light. Together they sketch figures that might be true. The first figure is pressure balance. A star's wind carries momentum outward. The surrounding galaxy carries its own pressure inward. Where the two meet, a surface forms that keeps the books even. Magnetic tension in the external field adds stiffness to that surface, while the star's internal magnetic spiral provides its own scaffold. In this picture, the frontier is a membrane pulled tight by competing hands. A narrow layer can then appear without violating scale. The thickness is set by how quickly particles trade charge, how strongly fields resist bending, and how swiftly turbulence can mix hot and cold parcels across the contact. A second figure speaks in the dialect of draping. An interstellar magnetic field approaches a blunt obstacle and slides along it. Field lines pile up and align with the surface. The strength rises, the direction steadies, and large rotations become rare. Charged particles do not easily cross field lines, so populations on either side feel separated even when geometry places them centimeters apart on an imaginary map. Cosmic rays with large gyroradii still wander across, but the bulk population behaves as if a gate stands closed. Draping explains a firm rise in field strength, a stable direction, and the way particle regimes switch without a dramatic compass turn. A third figure centers on charge exchange between ions and neutrals. Neutral atoms from outside drift inward. They can hand an electron to a fast proton from the star's wind. The donor becomes an ion that the magnetic field can corral. The recipient becomes a neutral that keeps its speed and flies away, carrying energy out of the sheath. This quiet trade cools the layer without bright signatures and leaves the frontier thinner than hydrodynamic estimates would suggest. Repeated exchanges build a population of pickup ions that curve into new orbits and can seed turbulence or carry energy as waves rather than heat. The ledger then balances without a wide, hot cushion. A fourth figure invokes reconnection, the process that cuts and reattaches magnetic field lines. Field lines from the star and field lines from the galaxy can merge at thin current sheets. Where they do, plasma gains access to shortcuts across the frontier. The result is porosity without disorder. Instead of a torn curtain, envision discrete doors that open and close with the rhythm of local instabilities. Particles find momentary corridors that equalize charge and pressure. When the doors close, the membrane looks crisp again. The overall frontier remains thin because reconnection distributes stress rather than letting it build into bulges. Transport theory adds a fifth figure, built from the mathematics of diffusion. High-energy particles do not drift at random. They scatter off magnetic irregularities whose sizes match their gyroradii. If the turbulence spectrum outside favors certain scales, then diffusion along the field becomes easier than diffusion across it. The result is a directional bias that shapes how quickly cosmic rays can invade the bubble. A sharper spectral cutoff at small scales produces a cleaner step at the boundary. A richer spectrum produces a blur. Observations of rigidity, dependent intensities, encourage a model where the outside offers smoother lanes than the inside, at least for the energies most easily measured. A sixth figure considers self-generated waves. Streaming cosmic rays can drive plasma instabilities that build their own scattering centers. In that case, the particle population sculpts the medium that regulates it. Near the boundary, where gradients are steep, the feedback can be strong enough to set a ceiling on the inflow. Waves rise until streaming slows, then decay when the gradient relaxes, then rise again when conditions favor growth. This feedback softens or sharpens the border, depending on how fast energy cascades through the wave spectrum. The effect can coexist with draping and charge exchange, adding dynamic texture without demanding a different architecture. Instabilities at kinetic scales bring a seventh figure. When pressure becomes anisotropic, mirror modes and firehose modes can awaken. These micro-instabilities rattle the plasma and rearrange momentum without lifting temperature in obvious ways. A thin draped layer is a natural home for such behavior because field strength increases and particle pitch angles shift as they cross magnetic gradients. The microphysics can regulate thickness, limit heat, and create faint, repeating signatures in wave instruments that masquerade as distant storm echoes. In this view, the border's crispness is not a single decision, but the net effect of many small self-corrections. A global shape emerges as an eighth figure. Competing silhouettes attempt to capture the whole bubble. A long comet tail emphasizes the sweeping flow of external gas. A blunt drum emphasizes external magnetic stiffness that resists bending. A crescent emphasizes pinched flanks, where magnetic tension gathers and funnels plasma away in two lobes. Each geometry changes how draping evolves and where reconnection prefers to occur. Each geometry sets where flux tubes might pierce the frontier and how quickly the distance to the membrane varies with latitude and longitude. The favored shape may be a hybrid, a drum faced into the oncoming flow with croissant flanks that channel stress, while a more modest tail carries shed material downstream. A ninth figure concerns the bright ribbon seen in energetic neutral atom maps. One interpretation places the ribbon where lines of sight are perpendicular to the external field, so the probability of detecting neutrals born from freshly exchanged ions peaks along a great circle. Another interpretation treats the ribbon as a retention zone, where pickup ions linger before turning into neutrals, producing a highlight that traces magnetic scaffolding near the border. Both options require a field outside that is coherent on wide angles, which aligns with a draped layer that favors continuity. The ribbon's existence then becomes a global signature of the same discipline that the local magnetometers report. A tenth figure regards sector structure inherited from the star. The spiral field inside flips polarity in a pattern set by the rotating source. Folded sheets can be carried outward and pressed against the membrane. Where they stack, reconnection becomes more likely, or diffusion across the border becomes briefly enhanced along aligned corridors. The craft senses them as quick switches and dips, while the global effect is to provide a controlled porosity that vents stress without losing the integrity of the surface. This accounts for hints of exchange without the chaos that a constantly shredded edge would create. An 11th figure studies the bow region upstream. If the external flow relative to the star is slower than the local fast magnetosonic speed, a true shock does not form. Instead, a bow wave builds, a soft cushion that preconditions the flow and field before they reach the membrane. That cushion can organize draping, align turbulence, and reduce the need for a wide sheath. If the flow is faster than the critical speed, a shock appears, and the downstream conditions become hotter and more chaotic, which would tend to thicken the layer. Present indications favor a gentle wave more than a hard shock in the local cloud. That choice supports thinness and order at the frontier. A 12th figure explores energy pathways. The missing heat may be hiding in fast neutrals that leave the scene, in waves that carry energy away along the draped field, and in pickup ion populations whose distributions do not look like simple thermal baths. Energy can also leave through reconnection jets that point along the surface, transporting momentum sideways rather than outward. None of these paths requires a warm sheath. All of them prefer a membrane that behaves like a well-tuned filter rather than a simple wall. A 13th figure proposes that the frontier is time-dependent in a disciplined way. Solar activity modulates internal pressure. External pressure fluctuates as the local cloud presents denser or thinner patches. The membrane moves in and out like the skin of a breathing animal. Motion over an astronomical unit or two can create the impression of a thicker or thinner boundary when sampled by a single trajectory. Predictions then focus on correlations between solar cycle phase, shock arrival cadence, and measured density outside. The pattern to expect is a frontier that translates more than it transforms. A 14th figure turns to universality. Other stars blow their own bubbles. The same vocabulary should apply. Magnetic draping will be common. Charge exchange will siphon energy wherever neutrals are present. Reconnection will create pores, and global fields will set the large-scale silhouette. The distribution of turbulence outside will decide how cosmic rays wander from bubble to bubble. Regions near dense clouds will host thicker drapes. Regions in hot, rarefied cavities will favor wider sheaths. Worlds inside will feel different levels of high-energy rain depending on how their bubble negotiates these terms. A 15th figure is the most speculative. The frontier may host long-lived flux tubes that tie interior and exterior fields in twisted ropes. These ropes could act as resonant waveguides, storing and releasing energy in quasi-linear bursts that masquerade as passing structures. If such ropes drift with the external flow, they would imprint recurring intervals in particle counts and wavetones, offering a new clock for a region that otherwise keeps time only with distant storms. The existence of these guides would unify many loose ends. A narrow layer could persist, while exchange remains efficient. Direction could stay steady while pathways open and close. Heat could drain sideways while the surface refuses to swell. These figures do not compete as much as they cooperate. A thin, draped membrane kept firm by pressure balance can host reconnection without becoming ragged. Charge exchange can keep the ledger cool, while self-generated waves regulate the inflow of cosmic rays. Sector sheets can drift in and raise porosity for an hour, then pass, while the global geometry holds. The frontier then becomes a system, not a single mechanism. The success of any explanation lies in how well it joins with neighbors to build a composite that carries all the signatures without strain. Darkness can carry storms. The star flings out eruptions that swell into traveling fronts, each a rolling compression of plasma and field. They leave the inner system bright, with auroras and radio hiss. Then keep going. Months pass. The front grows wider and slower as it feeds energy into the sea it crosses. A year passes, sometimes two. The remaining pulse reaches the far frontier as a softened fist. It presses the local electrons, and they answer with a voice no ear can hear. The voice is a clean tone that rises from wires on a small machine, a tone that turns empty space into an instrument. Shocks born at the star are not single arrows. They are suites of pressure waves carried on magnetic scaffolding, a layered battering ram of fast flow, followed by a drafted column of slower wind. As the ram moves outward, it gathers field lines like reeds before a boat. Ahead of it, the magnetic field tightens. Behind it, the field loosens and sighs. The leading compression does the essential work. When it pushes into a new region, the electrons there are upset and they oscillate as if plucked. Those oscillations have a natural pitch set by the number of electrons around. The pitch is high where density is high, lower where density is low. A small receiver that can hear the pitch has a direct yardstick for the local sea. The small receiver carries two long antennas that act as electric feelers. When a passing front shakes the electrons, the resulting motion drives a voltage along those feelers. The instrument separates hiss from song and looks for pure, narrow lines that mark resonance. It is a minimalist method. There is no need to count individual particles. The medium tells on itself by ringing. The timings of those rings form a ledger. Each line entry records the date a shock passed and the density it found. A sequence of entries becomes a profile with distance because the machine is always moving outward. Time converts to space, and a rude shove from the star becomes a measuring stick for the wider galaxy. There is a subtlety to how the shove travels. Inside the solar bubble, shocks are comfortable, swaddled in the star's own wind and guided by the spiral field. In the sheath beyond the termination shock, they slow and broaden. Some disperse into gentle pulses, others carry their identity with stoic persistence. The best of them live long enough to reach the border and then ripple through. When a front crosses from the inner domain to the outer medium, it sheds part of its energy as heat and part as waves. Enough survives to excite the plasma beyond, so the small receiver can hear an external tune rather than an internal echo. Arrivals are written as upward sweeps on a spectrogram, lines that climb in frequency as the front compresses electrons, and then ebb as the compression passes. The peak in the sweep gives the density at maximum squeeze. The floor between events gives the ambient level. By noting the rise times, fall times, and peak frequencies, One can tell whether the front was abrupt or leisurely, thin or wide. A sharp rise implies a shock with teeth. A slow incline hints at a wave worn smooth by long travel. Each style of arrival maps a different mood of the medium outside. These distant knocks serve as a kind of interstellar sonar. In a submarine, a ping leaves, and the echo returns. Here, the ping originates at the star, and the echo is a local ring when the ping finally arrives. There is no need to send anything. The universe supplies both the hammer and the bell. The small receiver need only listen, then match the timing with known eruptions. The match grows stronger when multiple observatories near the star log a large event. A calendar of coronal mass ejections and flares becomes a set of launch times. The faraway tones then become arrival stamps. From the separation between launch and arrival, one can infer average speeds across the immense distance. The numbers are not precise clocks, yet they narrow the range and confirm that fronts can travel hundreds of astronomical units before dissolving entirely. The method also reveals texture. Some tones arrive in clusters, suggesting a train of smaller compressions strung out along the same flow. Some arrive as solitary peaks that ring cleanly and vanish. Some rise to a plateau and hold for days before declining, an imprint of a broad, flat press. The diversity says that the path beyond the planets is not uniform. It hosts pockets that amplify or damp different wave styles, and layers that let certain frequencies through while smothering others. The small receiver becomes a weather station for a sea that no one can see, a sea that carries the memory of distant storms in long, low swells. Magnetic data deepen the reading. When a shock arrives, the field strength at the listening post rises in step with the plasma tone. If the field was already tight from draping, the increase may be modest, yet the coherence between tone and field confirms that a real compression is in the room. The direction of the field usually shifts only slightly during these episodes, a clue that the shove is mostly along the draped lines rather than across them. That behavior supports the picture of a disciplined frontier, where long-scale order survives, even as waves carry fresh stress across it. Particle counters respond as well, though differently. During a passing front, low-energy charged particles may be squeezed or deflected, creating dips or spikes that ride on top of the longer-term plateau outside. High-energy cosmic rays barely notice small compressions, but strong fronts can modulate even those heavy travelers, producing brief changes in arrival rate that reveal scattering strength in the surrounding medium. By comparing the amplitude of these modulations with the pitch of the plasma tone, the watchers estimate how elastic the local turbulence is, whether it bounces the visitors or lets them glide. Occasionally, the arrivals reveal something like a staircase. A first front reaches the listening post and triggers a tone that marks a given density. Weeks later, a second front arrives, and the tone peaks at a higher pitch, implying that the ambient density between events has grown. In such cases, the frontier seems to sit within a gentle gradient, perhaps a pressure slope in the local interstellar cloud, perhaps the imprint of long-lived structures that drift across the path. The sequence of steps builds a three-dimensional sense of the outside, all drawn from the patience of waiting for knocks. There is a practical beauty in the approach. The small receiver needs no calibration to a textbook lab standard. Nature provides the tuning. Electron oscillations have a frequency that depends only on the number of electrons, not on instrument gain or long aging. As long as the antennas and amplifiers remain honest, the tones can be read and compared across years. That robustness gives the measurements a gravity that is rare in remote space physics, where environments evolve on scales that outlast equipment and memory. The arrivals also explain apparent silences. Between shocks, the spectrogram can be quiet, and the absence tempts speculation. Is the region empty, or is it only waiting for a shove to sing? The method answers that the medium is always there, but it reveals itself fully only when pushed. The quiet times are not voids, they are interludes. When the next front appears, the same volume of space rings and tells its number. The interludes then become part of the narrative, the negative space that lets the positive lines stand out. A final use of these distant shocks is triangulation in spirit. Two listening posts in different directions may hear the same family of fronts at different times and strengths. Comparing their ledgers exposes differences in path, in preconditioning, and in local structure. One path might thread a region where the density climbs faster. Another might pass a pocket where turbulence eats the wave before it fully forms. Even without direct communication between the posts, their shared calendar of arrivals works like a parallax of time. The separation of perspectives cuts a rough shape out of the unknown. Shockwaves in darkness, long after their birthplace has turned to face other concerns, become tools in a kit for measuring a place that resists direct touch. They wrap the border in rhythm. They teach that the outside sea is not silent, only slow to speak. They argue that a star's influence extends not as a simple bubble, but as a drumhead that can be struck from within and heard from without. The listener drifts onward, and the knocks follow at their own pace. Each one adds a note to a growing chord, a chord that tells how tightly electrons keep company out there, how firm the magnetic scaffolding is, how far a storm can travel before becoming only weather. The darkness is not empty. It is elastic, and with each arriving wave it allows itself to be read. The music begins below hearing, a cathedral built from wavelengths longer than cities. Two slender antennas reach into the dark and feel the slow quiver of electrons as they sway in unison. Space is not a vacuum. It is a choir loft occupied by a thin congregation of ions and electrons that prefer to sing when pressed. The smallest shove becomes a chord. A drifting gradient becomes a drone. A passing compression becomes a bright, clean note that rises, holds, and fades. The instrument on the traveler registers these tones as lines on a spectrogram, faint at first, then clear, then layered, until the page looks like the staff of a score written by weather. Every voice in this choir has a name. There is the electron resonance, the purest pitch, a frequency set by how many electrons crowd a given volume. There are ion acoustic murmurs, slow and soft, lifted by the push and pull between pressure and inertia. There are whistler-like threads that slant through the chart when electric and magnetic forces twist around one another. There are hiss-like beds of noise that fill the lows and give the scene a floor. Alone, any one voice tells little. Together, their spacing and strength reveal density, temperature, and the tightness of the magnetic embrace. The language of the chart is simple. Higher pitch means more electrons. Wider bands mean stronger turbulence. Sharp, narrow lines mean coherence. When a passing front squeezes the local sea, the main tone climbs like a finger sliding up a string. When the front passes, the tone settles to a level that defines the ambient state. Between these events, the chart still speaks. Faint striations appear as packets of waves glide by, the fabric of the medium shivering in patterns that repeat often enough to count. Those repetitions are the signature of a structure that is not random, a texture with memory. Memory in a plasma comes from the paths of its makers. The outside is shaped by supernova blasts that raced outward long before anyone built a receiver. Their shock front seeded turbulence and left gradients that have not yet forgotten their push. Clouds met and sheared, folding magnetic fields into sheets that drift on the current of the interstellar flow. Cosmic rays stream along those fields and make their own waves, a feedback loop that can limit their speed and carve preferred lanes. The slow result is a sea where energy cascades from large scales to small, from broad flows to whispers, until damping finally turns motion into quiet heat. The receiver cannot see that cascade. It can hear its consequences. A spectrum heavy at low frequencies that thins toward higher ones hints at a cascade that shares a family resemblance with the classic laws of turbulence. Whether the slope follows one tradition or another is debated with care, because the medium is magnetized and almost collisionless, and the old laws were written for air and water. Yet the shape of the spectrum still argues for a transfer of energy across scales rather than a single dominant tone. Intermittent bright streaks suggest that the cascade is not smooth but punctuated, as if energy sometimes leaps across the ladder in sudden steps. Damping adds a quiet kind of punctuation. Landau damping, born when the speed of a wave matches the speed of some electrons and lets them steal energy from the ripple, can silence certain notes before they travel far. Cyclotron damping steals from others. The net effect is a filter that lets some melodies cross great distances while muting others in a few gyrations. The chart records the survivors. It is a biased history, but a useful one, because the bias is set by the local plasma and thus becomes a diagnostic. If the higher notes die easily, the electrons are cooler or the field is tighter than imagined. If they travel, conditions are looser and warmer. The sea is not uniform. Density fluctuates about a mean that rises with distance. The fluctuations are not neat. They skew and clump, forming a distribution that often looks log-normal, as if the medium has been multiplicatively stirred rather than additively salted. That kind of texture leaves its fingerprints on the spacing of tones and on the way wave packets grow and fade. The receiver sketches these fingerprints without knowing their names, and analysts ashore read them as signs of compressions and rarefactions stepping past in slow procession. At times the choir sings in harmony. 2 or 3 modes appear together, their intervals fixed, their growth and decay linked. Coupling between modes becomes visible. An ion acoustic murmur can feed energy into an electron resonance, raising a sideband that was absent before. A whistler thread can bend toward the main tone and fade as if paying tribute. Coupling implies that the medium's components are not strangers. Pressure, field, and flow are partners in a slow dance where a shove in one corner raises a foot in another. That dance stabilizes the frontier by spreading stress along many routes. Another reason the boundary can remain thin and yet endure. The choir also speaks of direction. Waves that drift along the magnetic field arrive with a different texture than waves that push across it. The receiving antennas are not omniscient, but even their limited geometry allows a faint sorting by polarization and arrival style. Patterns that favor along field propagation support the idea of a draped exterior, with lines of force running roughly parallel to the surface. The scarcity of broad cross-field shocks in the record agrees with a border that channels motion rather than welcomes it head-on. There is a mathematics hidden in the simplicity of a tone. The frequency that defines the main note scales with the square root of density. No calibration is needed beyond the honesty of the clock that measures time. That honesty is a quiet gift. Other instruments age in ways that require correction. The plasma wave receiver can play its roll of tape years apart and still count on the same conversion. A pitch that once meant a certain number of electrons still means it decades later. This steadfastness lets the ledger of tones serve as a clean ruler laid across an untidy world. Local events leave delicate embroideries on that ruler. Small, short-lived whistles may mark mirror mode pockets, places where pressure has grown anisotropic, and the plasma creates small magnetic hills to restore balance. Broader bands can be the droning presence of slow magnetosonic waves that travel the draped skin like surf along a shore. Faint notches can indicate places where damping has eaten a class of waves, leaving gaps in the spectrum that carry the shape of the devourer's appetite. Each feature is a whisper that, when tallied with others, writes a glossary for a medium that refuses plain speech. The choir's reach extends beyond one corridor. A second listener far away hears the same family of waveforms at different times and strengths. Comparing the 2 sets of pages, the differences draw a map of invisible currents. A tone that grows faster along one path implies a steeper gradient. A persistent hiss along another suggests a pocket of enhanced turbulence. When both listeners record a series of arrivals separated by weeks, their timing difference becomes a gradient meter for the entire frontier. With patience, the pair turns the choir into cartography. There are echoes worth savoring across disciplines. The same kind of medium scatters the radio flicker of pulsars, blurring their signals with a twinkle that betrays the spectrum of density fluctuations along the path. The chart from the traveler speaks to that twinkle. It suggests that nearby space shares the same proclivities seen across thousands of light years. Turbulence is not a rumor told at great remove. It is a local habit of matter and field. The choir is the same choir, whether heard from a probe at the edge or from a telescope aimed across the arm of the galaxy. The phrase foamy sea has a temptation to romance, but it holds a technical core. Foam is a set of bubbles and filaments, walls and voids, none uniform, all connected. The outside looks like that in numbers. Density climbs in terraces, magnetic strength gathers in folds, wave packets travel along corridors, and fall silent in rooms that absorb them. The traveler does not see the foam as bright or dark. It feels the foam as easy or hard passage for certain voices. A long swell travels, a short chop dies. The chart becomes a shoreline drawn by sound. All of this music points toward origins. Supernovae seeded the long wavelengths. Stellar winds and cloud collisions added mid-scale structure. Cosmic rays stirred small-scale ripples, as they tried to outrun their own influence. Time and damping softened the harsh consonants into a legible hum. The receiver does not need to know the history to read the present. The present is enough. It carries the sum of prior weather as a set of permissible notes. Those notes are the rules of the room, and the room is the space between stars within which a visitor now drifts and listens. The choir will fade as distance grows, power dwindles. The antennas cool. The line on the spectrogram will someday flatten into the baseline of instrument noise. Until then, the choir keeps proving a truth that matters. Emptiness in the galaxy is an active medium. It rings. It couples. It damps. It remembers. The tones on a small machine's tape are not ornaments. They are the grammar of that memory, sung quietly and read at leisure by minds far away that understand how a pitch can be a number and how a number can be a place. Edges in space rarely behave like smooth glass. They crinkle, they ripple, they gather into narrow lanes that carry stress like threads in a woven cloth. At a stellar frontier, the cloth is magnetic. The threads are field lines pressed into alignment by the oncoming flow of the interstellar medium. Where pressure climbs and the field tightens, the surface develops folds, each a ridge of enhanced magnetism and density, each a corridor along which charged matter prefers to travel. Between the ridges lie softer troughs where gradients relax. The whole sheet resembles a curtain lifted by a steady wind, with ripples that run, collide, and sometimes freeze into place. Corrugations begin where velocity shear meets magnetic stiffness. As the outside flow glides past the bubble, layers with slightly different speeds rub. The rubbing invites Kelvin-Helmholtz waves. Magnetic tension protests, trying to iron the wiggles flat. Neither side wins completely. The compromise is a series of long crests that drift across the face of the frontier. Along each crest, the field lines compress and turn more parallel to the surface. Charged particles find it easier to slide along those lines than to cross them, so the crests become highways where motion is guided and exchange is regulated. The troughs between crests become reservoirs where slower eddies linger and whisper. Folds also arise from the stacking of sector sheets carried outward by the star. Polarity reversals in the inner wind form large-scale current sheets. The outward flow presses those sheets against the frontier like stacked pages. Under external pressure, each page creases. The creases reinforce one another, creating filaments of high current that thread the boundary. Reconnection favors such places. When lines break and join, they carve short-lived funnels that link inside and outside. The funnels slide along the creases, like beads on a string, opening momentary doors that alter particle counts and field angles before the skin reseals. Not every ridge is the same size. Some span fractions of an astronomical unit. Others shrink to kinetic scales near the gyroradii of ions. The hierarchy matters. Large folds steer the overall traffic and set the posture of the frontier. Small folds dictate how quickly energy moves from ridge to trough and how often microscopic processes have room to operate. The coexistence of many scales is the mark of a living boundary. It lets the surface be thin and decisive, while still accommodating subtle exchanges that never grow into chaos. Charged dust contributes a delicate embroidery to this fabric. Grains that drift from the surrounding cloud absorb electrons and ions until they carry net charge. Once charged, they respond to the same fields that govern plasma. Their inertia is larger, their response slower, so they lag and bunch in predictable places. Folds become collection lanes where dust concentration rises. Those lanes alter local conductivity and modify how waves can propagate along the surface. A feedback takes shape. Dust gathers where folds focus the field. The altered conductivity then favors the persistence of the fold. In time, narrow, luminous filaments in energetic neutral atom maps can trace these lanes, faint fingerprints of grain-guided order. Filaments host gradients. Gradients host micro-instabilities. Where pressure becomes anisotropic, mirror modes may awaken, building small magnetic hills that reflect certain particle pitch angles. Where field-aligned flows accelerate, ion acoustic activity grows and dissolves, a restless hush that changes how easily heat can slide along the lines. In the presence of strong current sheets, tearing modes nibble at the edges, birthing chains of tiny islands that drift like foam cells. Each island is a knot in the curtain, a compact region where lines wrap around trapped plasma before reconnecting again. The passage of such knots past a listening post leaves crisp signatures that can be mistaken for distant storms unless the larger pattern of folds is kept in mind. There is a geometry to the way filaments align. Draping favors directions that trace the external field as it conforms to the obstacle. If the incoming field meets the frontier at an angle, the folds extend roughly along great circles that follow that angle around the bubble. The resulting network resembles latitude lines on a slowly turning globe, except the lines are elastic and shift with pressure. Where two families of folds intersect, X-like junctions appear that are ripe for reconnection bursts. Those bursts feed jets that run tangentially, exporting stress along the surface rather than through it. Energy leaves sideways, and the frontier remains narrow. A separate class of folds emerges from gentle buoyancy analogues. Pressure inside the bubble can vary with latitude and time. If a lighter region underlies a heavier region across the surface, magnetic tension can either suppress or admit a Rayleigh-Taylor-like wrinkling, depending on orientation. Where field lines are nearly parallel to the gradient, tension resists fingers. Where they curve across the gradient, fingers can grow. The fingers appear as short, stubby protrusions that then shear under the external flow and stretch into filaments. The process adds to the tapestry without demanding violent upheaval. The folds serve as waveguides. Slow magnetosonic waves slide along them with less attenuation than across them. Whistler mode packets prefer their interiors, where field strength and density gradients set comfortable indices of refraction. In such guides, wave energy can travel long distances with modest loss, redistributing momentum and smoothing sharp corners. The guides also filter the spectrum. Frequencies that do not fit the cross-section leak out and die. Frequencies that match hum for hours. The frontier becomes a harp strung with field-aligned strings, each tuned by local thickness and tension. Filaments regulate access for charged particles that attempt to cross the frontier. Along certain strands, diffusion across field lines is slightly less difficult, either because turbulence has grown to a friendly scale, or because reconnection has left lingering separatrices that act like ramps. Along other strands, diffusion is suppressed by ordered fields and quiet wave backgrounds. The mosaic that results looks like a border marked by gates and fences, each opening and closing with local conditions. The larger statistics of cosmic rays beyond the bubble respond to this mosaic in subtle ways, producing small biases in arrival directions and energies that survive long averaging. Dusty filaments may also act as chemical laboratories. Neutral atoms that wander into charged lanes can experience increased ionization or charge exchange rates. Those processes generate energetic neutrals that fly away on straight lines, carrying information about lane geometry to distant detectors. A faint correspondence between sky brightness in specific energy bands and the suspected alignment of external fields hints that such lanes are not only local curiosities, they are global features that give the bubble a visible frame when the right instruments look. The folds are not frozen. They drift with the external flow, creep under magnetic tension, and respond to pressure pulses from both sides. When a compression travels along the surface, it steepens crests and deepens troughs, then relaxes them as it passes. During these episodes, doors along the crests open more often. Exchange across the frontier becomes briefly easier. When the pressure relaxes, the doors close and the membrane recovers its tight stance. This dynamic keeps the region active without unmooring it. The surface breathes, it does not unravel. Field measurements along a single path cannot sketch the entire lattice, yet they can feel its granularity. Plateaus in strength suggest long ridges with consistent alignment. Quick switches betray crossings of narrow creases or small islands. Slow, repeating undulations point to trains of Kelvin-Helmholtz waves rolling by. Small dips in specific particle energies hint at momentary brushes with reconnection exhausts. Matching these features with the expected speed of the craft turns time into spacing, and spacing into a cross-section of the fabric. With two listeners in different directions, the textiles reveal more of their weave, because independent samplings of ridges and troughs differ in cadence and thickness. The existence of folds answers a set of practical questions. How can a surface be thin, strong, and yet allow measured exchange? By channeling stress into filaments that carry it away. How can density and field increase while temperature stays modest? By shunting energy into ordered currents, guided waves, and charge exchange in lanes where dust and ions collaborate. Why does the magnetic direction keep poise while particles change citizenship? Because draped ridges keep lines nearly tangent to the surface, permitting along field traffic while hindering cross-field leaps. The answers are not complete, but the fabric metaphor carries measurable content. Filaments and folds do more than decorate a frontier. They are its operating system. They decide how pressure is balanced, how heat is moved, how composition changes, and how the outside hears the inside and the inside hears the outside. They write their presence into every spectrogram and time series gathered at the edge, sometimes as bold strokes, sometimes as marginalia that only patience can read. In those markings lies a portrait of an interface that is not a wall. It is a textured, disciplined skin that both separates and connects. A skin whose wrinkles are not flaws but functions, carrying the memory of past winds and the promise of future weather. A border can hold and still breathe. The skin around a star is not a masonry wall. It is a magnetic membrane stitched from lines of force. Along that membrane, doors appear without hinges. They form where currents gather into thin sheets, and the electric field grows strong enough to cut and splice the lines. Reconnection does the surgery. Two fields approach with different ancestry, meet at a narrow X-shaped region, and exchange partners. The stitch completes, and a new pathway exists that did not exist a heartbeat before. Plasma follows the new geometry like rain follows a gutter. For a while, inside and outside are not separate. They are one continuous route. Such routes rarely sprawl. They form as flux tubes, ropes of connected field, and trapped plasma that thread the surface. Each tube has an entrance where lines link across, a body where flows accelerate, and an exhaust where stress is shed. The geometry creates speed. Pressure drops along the tube, drawing material as a siphon draws water. Particles that once spiraled on separate scaffolds now share a common spine. They can stream along that spine far more easily than they can hop across the membrane elsewhere. The border gains porosity without losing form. It leaks along chosen strands while the broader skin stays taut. Signatures of these corridors are subtle but repeatable. Magnetic strength rises at the tube's flanks and weakens inside, a small hollow carved by the jet. The field rotates briskly through a few degrees, then settles. Particle anisotropy swings as fresh arrivals align with the new direction of easy travel. Low-energy ions that had faced a barrier appear and then fade as the door closes. High-energy visitors show only mild nods. They are too independent to care much about a single invitation. The timescale is minutes to hours on a local clock. The spatial scale is a fraction of an astronomical unit. A craft drifting through does not see a grand portal. It feels a draft. The physics that lights these doors has a taste for parsimony. Where currents pinch, magnetic energy converts into particle energy. Some goes into bulk jets. Some goes into beams that run along the freshly joined lines. Some builds waves that scatter and heat. In a thin sheet with the right field geometry, reconnection can turn steady draping into a quilt of transient links. The rate matters. Too slow, and the border behaves like a sealed drum. Too fast, and the membrane would tatter. The observed steadiness of the field direction and the narrowness of the frontier argue for a rate that is brisk enough to vent stress and trade particles, but modest enough to keep order. Sector sheets driven outward by the rotating star prime the process. Polarity changes stack like pages against the membrane. Where neighboring pages touch, thin current layers form. External pressure pushes, internal pressure resists, and the sheet buckles into a chain of islands. Each island is a flux rope in miniature. As islands merge, X lines appear and vanish in a rhythm that opens a succession of short-lived corridors. The outcome is not a single gash, but a constellation of pinholes. Through each pinhole runs a brief pulse of trade. Over days and weeks, the pulses add up to a sustained exchange that relaxes gradients without erasing them. Neutral atoms join the traffic through a different loophole. A fast ion from inside can grab an electron from a neutral outside, become a fast neutral, and fly away on a straight line. Once neutral, it ignores fields and carries energy across the border, with no need for a door. The mirror process works from the outside toward the inside. These trades produce populations of pickup ions on both sides that then spiral on whatever field they find. Reconnection corridors enhance the effect by funneling ions into regions of higher neutral density, or into zones where charge exchange proceeds more freely. The combined routes make the membrane feel both selective and efficient. Porosity leaves patterns in the rain of energetic particles. When a door opens, gradients soften along the connected strand. Counts at certain energies dip or climb in a way that tracks the direction of the new link. The effect is not a storm, it is a nudge with a compass. Observers notice small shifts in the relative arrival from one side of the sky to the other. The shifts relax as the tube moves on or seals. With two listeners separated by many tens of degrees in longitude, the same family of tubes will brush one and miss the other. The differences in their ledgers speak to motion along the surface. A lattice of corridors slides under the receivers, and the timing of the slides becomes a crude map. Waves betray the same motion. When a reconnection jet sweeps past, the plasma wave receiver hears a faint packet riding on top of the ambient tone. It is not broad and noisy like a far-traveling compression from a stellar eruption. It is narrow, tidy, and brief. The packet often arrives alongside a quick rotation in field direction and a short-lived change in particle anisotropy. These clusters of signs repeat enough to suggest a shared parentage. The parent is the door, opening and closing with the tact of a heartbeat. Porosity also explains where missing heat can go. Instead of inflating a hot sheath, energy leaves sideways along connected strands. Jets carry momentum parallel to the membrane, not normal to it. Waves born in the exhausts run along the field lines and damp far from their birthplace. Charge exchange transforms ordered flow into neutral flight that departs without friction. A thin frontier can then endure, without storing the energy that models once assigned to it. The stiffness of the draped field supplies the strength. The doors drain the stress. The network of tubes does not erase discipline. Draping still rules the large-scale direction. Pressure balance still fixes the overall position of the membrane. Porosity rides on top of those controls. It gives the border a way to adjust locally, without reshaping globally. If external pressure steps up, more doors open for a while. If internal pressure slackens, the pattern thins. Solar cycle changes, shock arrivals, and slow movement through the local interstellar cloud can all modulate the duty cycle of doors. In busy seasons, the frontier exchanges more breath. In quiet seasons, it holds itself with fewer murmurs. Flux tubes can last long enough to act as guides for other processes. A corridor that stays open for hours allows slow magnetosonic waves to travel within it, redistributing pressure and smoothing corners. It allows charged dust to drift into the path and change local conductivity, which in turn influences where the next reconnection prefers to spark. It allows pickup ions to form beams that seed micro-instabilities. Those instabilities add scattering centers that temporarily enhance cross-field diffusion for a narrow range of energies. The corridor becomes a narrow ecosystem, tuned by its own traffic until it fades and another takes its place. The balance between openness and control carries strong implications for anything that lives within the bubble. A membrane with controlled porosity modulates the rain of galactic particles rather than simple shielding them or admitting them. The modulation is energy dependent. Some energies are buffered strongly by the network of doors and waves. Others slip through, almost as if no border existed. The pattern is not academic. The chemistry of atmospheres, the charge state of dust, and the ionization of outer clouds within the bubble all feel the touch of that filtered rain. Over long times, the membrane's temperament writes itself into climates and slow geologies that never see the frontier directly. There is a lesson in the apparent gentleness of these exchanges. A door opens. A jet slides past. A tone tightens and relaxes. A count dips and recovers. Nothing explodes. Yet across thousands of such small episodes, the border's identity is maintained. The outside learns what lives within. The inside learns what presses from without. The flow remains balanced, and the membrane stays narrow. The region survives through a practice that resembles breath more than battle. Pressure in, pressure out. Link, unlink. Carry, release. It is a choreography made from field geometry and patient time. Porosity keeps the frontier honest. Without it, gradients would steepen until something tore. With it, the membrane can tune itself. The stitchwork of reconnection tubes, charge exchange flights, and wave-guided drains gives the skin around a star the flexibility of living tissue. That tissue separates worlds from the wider sea and connects them at the same moment. In each brief corridor lies a proof that separation and exchange are not opposites. They are partners in the equilibrium that lets a bubble exist at all, a bubble that moves through the galaxy with its doors briefly open, then closed, then open again, and still whole. A ribbon appeared across the sky where no ribbon belonged. It arced like a pale band in maps of particles that no eye can see. Energetic neutral atoms were the paint. They are born when a fast ion steals an electron from a slow neutral and steps out of the magnetic harness as a free traveler. Uncharged, they fly in straight lines from their birthplace to any detector that waits with enough patience. When an observatory near Earth counted these neutrals and charted their arrival directions, the chart did not come back as a soft glow. It returned with a bright, narrow arc that wrapped the sky and insisted on a geometry larger than the machines that noticed it. The arc prefers directions where the line of sight stands nearly perpendicular to the magnetic field that envelops the star. That preference is no accident. Charged particles gyrate around field lines and leave signatures that depend on pitch and angle. Where the view cuts across the field at right angles, the odds of catching a newborn neutral rise. The field outside the bubble therefore acts like scaffolding. The ribbon traces where that scaffolding presents its side to the observer. To sketch such a band, the external field must be coherent over enormous spans. Disorder would smear the signal, order sharpens it and holds it steady through the slow seasons. There is a second ingredient beyond geometry. Pickup ions gather near the frontier. These are neutral atoms that drifted in, lost an electron, and suddenly felt the grip of the field. Their motion turns into a tight spiral, plus a drift along lines. Before they thermalize, they carry memory of where they were born and how they were pushed. Many of them become neutral again in short order through another exchange. The newborn neutrals depart in directions linked to the magnetic frame that shaped their brief charged life. If those births occur preferentially where the field lies perpendicular to the line of sight, a ribbon emerges as a retention zone for pickup ion energy and a fountain for neutrals aimed back at the detectors. A third ingredient is pressure. Where draped field lines pile up against the bubble, plasma pressure and magnetic tension both rise. The pile-up slows, charged flows, and raises the chance that an ion will meet a neutral and make the switch. The newly minted neutral inherits the speed of the ion and heads outward on a ballistic path. A detector that counts neutrals by energy and angle will thus see enhancements where the pileup is strongest. The ribbon then becomes a pressure contour, mapped by particle flight rather than by light. Its curvature sings of how the external field bends around the obstacle. Its width tells how thick the pileup zone is before the medium relaxes into the wider cloud. Different energies draw slightly different ribbons. Lower energy neutrals probe nearer to the skin. Higher energy ones can carry news from deeper into the sheath and from the beginning of the interstellar flow that brushes past. The multi-energy map reveals a subtle parallax. The band shifts and thickens with energy because the origin distance and the time spent as ions both change. This parallax gives an extra handle on the depth of the emitting region and the vigor of the processes that feed it. It also supplies a clock, since the time between an ion's birth and its second exchange controls how long memory of angle can survive before collisions blur it. The ribbon's persistence argues against a transient cause. Solar activity cycles and shock passages do modulate its brightness, but the arc remains in place, anchored to a direction in space rather than to the changing moods of the star. That anchoring points to the external field as the true frame. When the star's wind blows harder, the membrane pushes outward, and the local conditions shift. Yet the band's spine keeps faith with the larger magnetic discipline of the surrounding medium. In that steadiness lies a way to read the field without touching it. The ribbon is a compass drawn in particles. Other instruments added weight to the interpretation. A camera aboard a distant spacecraft sensed energetic neutrals at somewhat higher energies and found enhancements that echoed the same great circle. The echo showed that the phenomenon is not a trick of one machine or one energy band. It is a real arrangement in space, reinforced by independent eyes and by the fact that its location follows expectations of where a draped field should present its broadside when viewed from within the bubble. Not every detail yields easily. Some models favor the idea of secondary neutrals. In this scheme, ions born outside cross into the sheath, become neutrals, recross the frontier, then become ions again, and finally neutrals once more in the draped pileup. Each switch rotates the memory of direction and alters the chance of aiming toward the detectors. The cascade can sharpen a band and make it brighter than a single exchange would allow. Other models emphasize a simpler retention effect. Pickup ions linger where the field is perpendicular and exchange there, with no need for multiple crossings. Both paths can produce a ribbon. Disentangling them demands close attention to energy spectra, to the band's width, and to its small-scale mottling. Mottling matters because it hints at structure in the pileup. The band is not perfectly smooth. It carries knots and dimples that move slowly with time. Those features suggest folds and filaments in the draped layer, where density and field strength vary on scales that matter for charge exchange. In places of higher density, the switch from ion to neutral happens more often. In places of stronger field, pickup ions spend longer times in organized motion before randomization. The pattern of bright and faint along the band thus becomes a coded map of wrinkles at the frontier that no magnetometer alone can resolve from afar. There is an asymmetry written into the arc. On the side that faces the incoming interstellar flow, the band tends to be brighter and narrower. On the downwind side, it softens and spreads. This agrees with a face that bears the brunt of pressure and a flank that relaxes into a slower gradient. The asymmetry does not prove a long comet tail, nor does it forbid one. It simply records that the upwind prow is a place of discipline where the field stacks firmly, while the lee permits a more open weave of currents and exchanges. Global shape is involved, but the ribbon is particularly sensitive to field orientation rather than to the absolute silhouette. The brightness changes with the star's own weather after a delay. Time is needed for solar activity to reshape the interior, launch shock trains, and nudge the membrane outward or inward. Time is also needed for pickup ion populations to refresh. When disturbances arrive at the frontier, they can thicken the pileup and tighten the field for a season, raising the band's intensity. As the disturbance passes, the band relaxes. The delay supplies another ruler. Matching fluctuations in the band to known epochs of interior activity helps estimate the speed of communication through the sheath and across the draped zone. The ribbon implies an angle for the external field relative to the star's motion and rotation. Fitting the band's great circle with models of draping yields a direction in the sky for the field far from the bubble. That direction can be compared with starlight polarization and with radio measurements of Faraday rotation through the local cloud. Agreement across methods strengthens confidence that the particle compass is pointing true. Disagreement forces revisions in assumptions about neutral densities, charge exchange rates, or the way pickup ions pitch their final ball toward the detectors. The arc also answers a hard question about the missing heat at the border. If energy were stored as local temperature in a fat sheath, the band's contrast would likely be muted by a flood of neutrals from a wide zone. Instead, the contrast is high, and the origin region seems thin. This supports a frontier that exports energy through directed flows, reconnection jets, and fast neutrals rather than one that sits as a warm cushion. The bright line becomes a negative space of a sort. It signals where order prevails and where energy prefers motion over storage. Future instruments are poised to refine the picture by counting more neutrals with better energy resolution and by tracing small temporal changes that earlier maps could not capture. As those maps grow, the band's slow shifts will serve as a barometer for changes in the field and density of the local cloud. The ribbon is then more than a curiosity. It is a tool for watching the state of space, outside the bubble, and for watching how the membrane answers. The secret is not mystical. It is practical. A band appears because field lines wrap, because ions and neutrals trade places with rules that respect that wrapping, and because a detector can decode the trades by measuring flight directions and energies. The beauty lies in the scale. A small instrument near a pale planet can read the posture of an invisible field that spans dozens of light years simply by counting the arrivals of particles that carried a single electron across a border and then came home. In that reading, The scaffolding around a star becomes visible without light, and the shape of a protective bubble acquires a bright seam that reveals its stitching. A bubble can wear many faces, and each face says something about the tug of winds and the discipline of fields. One face is a comet, long and streaming. Another is a croissant, pinched at the flanks with two rounded lobes. A third is a drum, blunt and almost symmetrical, held in place by a firm external grip. The choice among them is not decoration. It is a ledger of how pressure, magnetism, and sparse matter negotiate a frontier that no eye can see. Instruments whisper clues. Models answer with shapes. The comet tells a simple story. A star exhales. The surrounding medium flows like a river from one direction. A bow region forms on the upwind side, and the downwind side stretches into a tail that thins and fades. In this picture, the wind pushes hardest at the prow. Behind, the flow is shed and drawn into a long wake. Charge exchange cools the sheath, but does not erase the logic of a river bending around a rock. If the local flow was strong and the external field gentle, the bubble would lengthen naturally. A tail would gather pickup ions and carry them far downstream. Energetic neutral atom maps would display an upwind brightening and a downwind extension. Cosmic rays would find a longer sheltered corridor along the lee, with a slower approach to the outer density. The croissant proposes a more intricate balance. Internal magnetic tension pinches the bubble along its equator. External pressure adds its own squeeze. Two lobes inflate above and below the plane, like halves of a pastry set side by side. The flanks host the tightest press, and flows are redirected into two plumes. The upwind face remains blunt, but the downstream region does not become a single tapering tail. Instead, the bubble sheds material through twin outlets that curve away. This geometry arises when the star's magnetic field, wound into a spiral by rotation, stiffens the interior against cross-field expansion. The stiffness resists a simple stream-like wake and favors paired exhausts. In this view, the frontier remains relatively close in the equator and extends farther in polar directions. The drum appeals to the authority of the external field. If the interstellar magnetic field is strong enough relative to the flow, draping becomes dominant. Lines bend around the prow and align with the surface. Magnetic pressure adds to gas pressure until the sum halts the wind in a compact region. Downstream, the field prevents a long wake from developing. Instead, the bubble becomes a nearly closed volume, slightly elongated along the field, but far from the dramatic taper of a comet. Energetic neutrals form a band where the view cuts across the drape. Cosmic ray access responds more to field orientation than to distance to the skin. The drum is the face of a frontier managed by tension rather than inertia. Evidence can be weighed against each silhouette. A long tail would produce persistent signatures of downwind extension in particle maps across many energies. The signatures appear muted or ambiguous. A strict drum would keep the frontier almost equidistant in many directions. Crossings are not equidistant. The croissant predicts flanking pinches and polar leaks. Maps of energetic neutrals show asymmetries that could belong to such pinches, and the bright ribbon favors a geometry where the external field frames the view with a consistent angle. Local density outside the skin rises with distance in a way that argues for a firm drape and a thin sheath, a point in the drum's favor. Yet hints of extended flows refuse to vanish entirely, a nod to twin outflows or to a modest tail. Solar cycle complicates every outline. Internal pressure waxes and wanes with the activity of the star. The membrane breathes. A comet face would lengthen and shorten. A croissant would widen and tighten at the flanks. A drum would translate rather than distort, keeping its blunt posture while shifting in and out. Time series of particle counts and plasma tones suggest that translation is important, but not the whole story. Small shape changes are required. Pressure pulses thicken the pileup and then relax it. The response resembles a drumhead that tightens and loosens under a drummer's hand while the basic circle persists. Yet the flanks do reveal episodes of enhanced exchange that look like brief openings for exhaust. Neutral atoms set their own scale on the debate. Charge exchange siphons energy from the sheath and creates fast neutrals that escape without friction. If such cooling is strong, the sheath cannot inflate into a fat buffer. Thinness becomes likely, and a thin sheath aligns with draping, and a compact upwind face. Thinness also encourages reconnection to vent stress along the surface rather than outward. That preference keeps the global form tidy. A long tail needs room to develop. A thin sheath denies it. The croissant survives this constraint by letting outflows follow the path of least magnetic resistance rather than insisting on a single downwind tunnel. Field direction places heavy weight on the scales. The bright ribbon of energetic neutrals traces a great circle that aligns with lines of sight perpendicular to the external field. Such a circle is easier to maintain across time if the bubble presents a broad, disciplined, draped layer. A tail would twist and wander with downstream turbulence, smearing the circle. A drum preserves the circle with dignity. A croissant preserves it with a small twist that depends on latitude. The observed steadiness argues for a strong external frame and against a wildly wandering wake. Crossings by distant listeners are decisive in spirit, even if few. One path met the skin farther out in a quieter season. Another met it closer in during a busier season. Both recorded a thin boundary and a persistent magnetic direction just outside. The consistency of the direction favors a draped exterior rather than a riot of eddies. The thinness favors energy export and a firm pressure balance. These traits lean toward drum-like behavior at the prow. They do not decide the far shape. For that, distant maps must be read like silhouettes cast on a wall by particles instead of light. Transport of cosmic rays offers an indirect verdict. If a long tail dominates, diffusion barriers along the lee should create prolonged anisotropies at selected energies, with a directional bias that remains steady over long averages. If a drum dominates, anisotropies would correlate more with field geometry than with downwind distance. If a croissant dominates, two preferred directions would appear at high latitudes, with subtle shifts as the internal field evolves. Observed biases tend to follow field cues more than distance cues, which strengthens the case for a strong drape and reduces the appeal of an extravagant wake. A useful synthesis accepts that the bubble is not locked into a single metaphor. Upwind it behaves like a drum, blunt and compact under magnetic discipline. Along the flanks, internal tension pinches the surface and guides outflow into two lobes, a croissant signature. Downwind the structure likely extends, but not as a single filament. It relaxes into a modest, perhaps braided wake, shaped by the same field that rules the prow. In this hybrid, the skin remains thin, the drape remains coherent, and exchange occurs along corridors that favor certain latitudes. Such a hybrid has consequences. The rain of high-energy particles is modulated by the angle between field and surface, rather than by sheer distance to the skin. Regions under the lobes experience different filtering than regions under the flanks. Shock waves, traveling out from the star, strike the prow and run along the drape like surf down a beach, focusing energy near the flanks and then sending quieter swells into the lee. Energetic neutrals carry back a portrait with a bright upwind band and softer downwind features that shift with energy. The chemical and electrical states of the far outer clouds inside the bubble acquire a quiet latitude dependence. Universality waits in the wings. Other stars move through other clouds with other field strengths. Some will wear comet faces because their surroundings are hot and thin and their fields relaxed. Some will wear drums because their neighborhoods are stiff with magnetism. Many will wear croissants because rotating winds impose tension that prefers lobes. The language learned in one bubble can be translated. Astrobiology cares about that translation because the filtering of cosmic rays by each silhouette changes the climate of radiation across distant worlds. The choice among comet, croissant, and drum is not a vote for taste. It is a distillation of equations into posture. The better the measurements of density, field, and particle flow, the sharper the silhouette becomes. Instruments keep adding lines to the drawing. They say the sheath is thin. They say the field is well behaved outside. They say outflows exist but prefer certain corridors. They say a bright band marks where the drape turns its side toward the observer. A clear image forms slowly from these strokes. It shows a bubble with a disciplined prow, pinched flanks, and a restrained wake. The face is neither a long arrow nor a perfect circle. It is a crafted shape, tuned by tension and exchange, made to travel through the galaxy without losing itself. Hints about the wider galaxy arrive as side effects of careful listening. A small craft reports local density, field strength, and particle rain, and those reports become clues to how matter and magnetism behave far from any star. The most immediate clue is pressure. Outside the star's sphere, plasma pressure and magnetic pressure combine to a value that can be read from the stiffness of the frontier. That number speaks to the state of the local cloud, which is a stitch in the fabric of the galactic disk. If the pressure is higher than once supposed, then nearby interstellar gas is less fragile. Clouds can hold their shapes longer against supernova shudders, and the balance between warm and hot phases must be adjusted. Catalogues of cloud density and temperature then need a new column that grants the magnetic field a larger share of control. The second clue is the scale of order. Measurements show a field outside that holds its direction with surprising courtesy, as if guided by a larger architecture. Such courtesy implies a coherence length that extends across a meaningful slice of space. A long coherence length changes how charged particles spread. They follow the grain over larger distances before random walk dominates. Transport coefficients used in models of cosmic ray propagation across the disk must then respect a stronger anisotropy. Diffusion along the field becomes favored. Diffusion across becomes slower. And the map of where cosmic rays arrive at a given time grows more filamentary than spherical. Spectra of turbulence contribute a third clue. The waves and hisses that drift past the receiver imply a cascade shaped by magnetized, almost collisionless physics, rather than by the familiar viscosity of air or water. The slope of the cascade fixes how energy injected by distant events is processed as it travels. If the slope is steep, small structures dissipate quickly and leave a cleaner, quieter medium for long waves. If the slope is shallow, small eddies survive and decorate the path of cosmic rays with more traps. The observed ability of long wavelength compressions to travel for years suggests a cascade that spares them, which in turn encourages models where supernova remnants communicate their pressure over larger volumes than previously assumed. Density that climbs with distance from the frontier offers a fourth clue. The climb reveals a gradient in the local interstellar cloud, which may be a flank of a larger cavity. That geometry recalls the structure known as the local bubble, a region carved by ancient explosions that left walls of denser gas. If the frontier is walking up such a wall, then the Sun and its companions do not drift in a uniform sea. They swim through patchwork. The implications reach into star formation, because the pressure and field at the edges of bubbles shepherd neutral gas into filaments where gravity can take hold. A slightly stiffer edge changes the odds that a cloud fragment will collapse into a nursery. The small craft, by reporting a local slope, gives a nudge to the story of where new stars decide to ignite. A fifth clue lies in the fate of heat. The apparent absence of a wide, hot cushion at the frontier argues that energy is exported efficiently through directed flows, fast neutrals, and waves. That export is likely common in other stellar bubbles. If so, the galactic network of overlapping winds behaves less like a froth of warm pillows, and more like a lacework of membranes that trade stress without hoarding it. Such a lacework would let supernova shocks run longer inside cavities before they fade, which would alter the reach of chemical enrichment, dust processing, and the acceleration of cosmic rays. Global simulations that try to grow spiral arms and molecular clouds must then prefer mechanisms that move energy sideways and away, not only into local heating. The ribbon traced by energetic neutrals provides a sixth clue. Its alignment with directions perpendicular to the external field presents a sky-size compass for the neighborhood. When the compass is compared with polarized starlight, and with Faraday rotation in radio surveys, a reasonably consistent direction emerges for the field across dozens of light years. Agreement across methods strengthens the case for a magnetic spine that threads the local arm segment. A spine like that affects how superbubbles from clustered star formation inflate and merge. It steers their growth along preferred azimuths. On larger scales, such steering contributes to the observed alignment of elongated molecular clouds and to the tendency of young stellar strings to form with a family resemblance in orientation. Cosmic ray composition offers a seventh clue. Small changes in the relative abundance of secondaries to primaries among the high-energy arrivals outside the star's bubble translate into estimates of the grammage that particles have traversed. Grammage is the mass of material encountered along the path. If the outside allows easier streaming along ordered fields, The effective grammage needed to produce the observed secondaries may be lower than older models assumed. That implies either shorter residence times in the disk for some energies, or a transport that spends more time in low-density corridors. The result feeds back into interpretations of gamma-ray maps and into efforts to apportion the roles of sources and propagation in setting the spectrum observed near Earth. An eighth clue concerns the ubiquity of bow regions. The conditions inferred near the frontier favor a bow wave rather than a strong bow shock ahead of the bubble. If that choice is common, then many astrospheres across the galaxy will be bounded by soft cushions rather than by hard breaks. A soft cushion organizes draping and promotes thin membranes. Hard shocks thicken sheaths and brighten charge exchange signatures. Surveys of other stars that show muted, neutral emission in expected bow directions may therefore be telling the same story. Most stellar bubbles move through warm, partly ionized clouds at magnetosonic speeds that invite waves, not discontinuities. A ninth clue flows into astrobiology. The membrane surrounding a planetary system filters the high-energy rain that reaches the outer clouds and then the worlds within. A border that modulates rather than blocks creates a variability that rides on the solar cycle and on the slow drift through clumpy clouds. That variability adjusts the ionization state of upper atmospheres and of cometary comas. Over geological spans, it can nudge climate through slow changes in cloud microphysics and through chemistry that seeds or sterilizes prebiotic pathways. If such modulation depends strongly on the angle between field and membrane, then planets at different latitudes within a bubble may experience subtly different radiation climates. The concept of a habitable zone gains a quiet geometric footnote. A 10th clue addresses universality. Numbers extracted from one frontier scale with basic parameters. Replace the star's wind speed and magnetic flux. Replace the external field and density, and the same equations predict different sizes, shapes, and porosities. The laboratory at hand becomes a template. Small red dwarfs with modest winds will host compact membranes that yield quickly to external pressure. Hot young stars will carve wide cavities where draping still disciplines the prow. Planets around both will live under filters tuned by the same physics, with different settings. The clue is not romantic, it is practical. A catalogue of membranes can be built from a short list of inputs. An 11th clue refines the story of how supernovae accelerate cosmic rays. If wave energy can travel long distances along draped fields, and if reconnection and charge exchange carry stress without heat, then regions far from a remnant can still feel a push that stiffens the medium. Cosmic rays, streaming away, encounter a background already primed with waves at comfortable scales, which raises the efficiency of confinement and the chance of further acceleration by scattering. The large-scale structure of fields and membranes becomes part of the accelerator, not just the afterglow. Gamma-ray halos around remnants must then be modeled with field-guided transport that honors what a small craft has measured near home. The 12th clue returns to time. The frontier responds to cycles and shocks with delays that can be clocked. Those delays constrain how quickly information moves through hot cavities and draped skins. Translate the delays into speeds, and those speeds into viscosities and conductivities, and whole classes of assumptions in galactic simulations must be tuned. The tuning changes the thickness of spiral arms, the height of the ionized layer above the disk, and the rate at which chimneys vent energy into the halo. In this way, a tone recorded by a distant receiver edits the weather forecast for regions that no instrument can touch directly. A 13th clue is the reality of thinness. Membranes at stellar edges can be narrow and yet stable when magnetic tension and pressure balance cooperate. If that is common, then interfaces throughout the interstellar medium may be thinner than images imply. Contact discontinuities between clouds, boundaries of superbubbles, and magnetopauses of planets that orbit other suns might all be maintained, not by padding but by discipline. Thin boundaries with organized drape shed less light, which explains why many expected shocks have proven elusive in emission surveys. The absence of a bright rim becomes evidence for a tidy frontier rather than for a missing one. A 14th clue invites humility about maps. 2 points of entry into the outside do not define a global truth. Yet the consistency between them, when combined with sky-size particle portraits and long-range radio surveys, argues that the local part of the galaxy is stitched by fields that care about geometry. Pressure is not a scalar that floats. It is a tensor that leans. Winds do not stop cleanly. They negotiate. Particles do not wander blindly. They follow a grain before they stray. The galaxy then appears less like a fog and more like a wood grain, with long lines that guide tools and stains in predictable ways. These clues accumulate into a single message. A star's frontier is a lens through which the galaxy becomes legible. Density, field, and particle rain are local facts, yet each fact scales outward to shape how bubbles touch, how shocks travel, how cosmic rays find their paths, and how new stars choose their cradles. The lessons are not abstract. They will alter the constants in models, the priors in surveys, and the expectations for worlds that live under different suns. A small craft, carried far by patience, has shown that the road between a number and a galaxy can be as direct as a radio line across darkness. Fresh instruments widened the stage and taught new ways to listen. One set of ears sat near Earth and counted energetic neutral atoms. Another prepared to fly with finer resolution and a deeper range. A distant scout in the outer system carried sensors that tasted the wind where light had grown thin. Solar observatories watched eruptions at their birth and kept calendars that could be matched to far arrivals. Computers turned empty rooms into theaters for equations, then projected test skies that could be compared with what the real sky returned. Together, these tools stitched a broader atlas of the star's boundary with its galaxy. An imager that never leaves near-Earth orbit drew whole sky portraits from invisible projectiles. Energetic, neutral atoms have a gift. They travel in straight lines with their energies intact, carrying the imprint of the place where they were born. By counting them in narrow energy bands and sorting them by arrival direction, the imager built a set of maps that showed bright and faint regions like weather on a globe. A thin band arced across those maps, a steadfast ribbon that marked where geometry and draping favored the making of neutrals. Away from the band, patches pulsed slowly in response to seasons when pressure rose or fell. The instrument repeated its census year after year. Change was real, but form endured, which spoke of a frontier ruled by geometry more than by whim. A successor promised finer eyes and a longer reach in energy. Its plan is simple and bold. Sweep the same sky with better angular resolution, many more energy steps, and faster cadence. Calibrate with care. Tie each count to a clock and a pointing history, so honest that small shifts become legible. With that precision, the ribbon that once looked like a single stroke becomes a braided seam, with knots and width variations that betray the wrinkles of the draped field. Regions away from the band reveal their character as sources tied to specific processes. Pick up ions that linger. Reconnection exhausts that vent stress along the surface. Cooling lanes where charge exchange is efficient. The atlas grows from rough outline to fine etching. A small explorer in the Kuiper realm contributed a different perspective. Its sensors taste the solar wind far from home and measure how the flow slackens, warms, and occasionally feels the far echo of a core eruption. It counts low-energy ions and electrons. It watches the faint ultraviolet glow of hydrogen spread across darkness. Each measurement adds a midpoint between the inner system and the frontier. With those midpoints, modelers can test how shocks age as they travel, and how long they can still ring electrons when they finally reach the membrane and set off a tone. The explorer does not need to approach the border to matter. It provides a ruler for the journey and a reason to trust the timing. Closer to the sun, coronagraphs and heliospheric imagers watch eruptions gather into fronts and move outward as pale halos. Radio instruments measure the crackle of shocks near the star and the softening hiss as they stretch away. The events are stamped with time and given speed estimates that begin crude and grow steadier as they advance. A calendar forms from these births. The calendar is then aligned with tones heard far away and with changes in particle counts at the edge. The match is never perfect. It is good enough to reveal speeds and to show which kinds of eruptions survive to the frontier. The union of inner and outer watchers turns a single eruption into a multi-stage experiment that measures how a complex structure degrades and yet keeps a core identity across 100 astronomical units. Radio astronomy supplies a complementary test that does not rely on the star at all. Pulsars and compact galaxies act as backlights. Their signals twinkle and smear as they cross irregular plasma. The statistics of that twinkle reveal how density fluctuations are distributed across scales. The part of the path near home contributes its share. The story told by the twinkle agrees with a medium that is magnetized and disciplined. It argues for a spectrum of fluctuations whose low frequencies travel well and whose higher notes damp in the manner seen by the receivers on the traveling craft. The backlights tell truth across thousands of light years. The frontier measurements say the same truth lives next door. The hydrogen line in ultraviolet adds another page. Scattered glow around the star reveals a compression of neutral atoms that pile up against the outer skin. Spectra record a small shift in that glow. The shift is a signature of a warm, denser layer where neutrals slow and mix. The images write a ghostly silhouette of the prow. The silhouette is not bright enough to be called a photograph. It is clear enough to constrain thickness and shape, and to confirm that a genuine pileup exists where the draped field presses hardest. Computers act as interpreters in this growing congress. Equations for magnetized gas, ions, and neutrals are written into codes that run for weeks. Each run is a proposition. Change the strength of the external field and the composition of the local cloud. Change the rate of charge exchange. Change the speed of the stellar wind. Out of these choices, the code returns a living boundary. Then tools synthesize fake datasets to match what instruments would have seen. Fake neutral maps. Fake plasma tones at the locations of distant listeners. Fake changes in cosmic ray counts at selected energies. The fakes are scored against reality. A high score means a step toward a true map. A low score sends the model back to school. There is a special power in combining maps made from particles with lines made from sound. Neutral atom portraits show where the production of fast neutrals is efficient. Plasma tones mark where electron density climbs. Field measurements, bracket strengths, and angles. Particle counters measure spectra that change when diffusion regimes shift. With those pieces, testable statements form. The draped field should lie along a great circle that the neutral maps already hint at. The thickness of the skin should be small, or else the band would smear. The upwind side should show higher density that rises with distance, or else the tones would not climb as they do. The new imager will decide whether the knots in the band match the wrinkles that field theory predicts. The outcome will either bless the hybrid silhouette of Drummond lobes or force an amendment. Ground detectors of high-energy particles add another balance check. Arrival directions of cosmic rays vary a little over the course of years. Some of that variability comes from the inner spiral. Some comes from the membrane's conduct. As the new imager refines the drape, predictions for those small directional biases gain bite. If counts from the north shoulder of the sky rise when the band brightens along a certain arc, the case for a specific set of gates across the boundary strengthens. If they do not rise, the idea of those gates must be narrowed or replaced. Other stars provide control tests. Ultraviolet instruments find bow regions and thin skins around bright neighbors. Their shapes differ. Some show long wakes, some do not. Charge exchange glows around them are bright or faint depending on the pressure and speed of the local medium. By fitting those glows with the same family of models used for home, the universality of the physics is tested. A single set of rules that fits many stars becomes more likely to fit this one with confidence. A rule that fits no one else needs repair before it can be trusted in any particular case. Timing remains the quiet hero of every test. When the inner system erupts, when a mid-system scout feels a squeeze, when a far receiver hears a tone, when a sky map brightens along a band, when a ground array sees a small change in the arrival of heavy visitors, each moment is logged and compared. Lags become distances. Correlations become proof that different instruments are seeing different faces of the same play. The web of timing turns scattered facts into a structure that can be touched by mathematics. There is no single machine with the whole answer. The atlas grows because many types of listening do not overlap, they interlock. One ear hears a tone. One eye sees a ribbon. One hand measures a field that refuses to twist wildly. Another hand measures a wind that carries shock trains for years. Another counts neutrals born in lanes where charge exchange is more eager. A lab of silicon solves the equations and offers mock skies that must face audits by the others. Bit by bit, the border becomes less rumor and more map, less symbol and more place. The new tests do not chase spectacle. they pursue clarity. They turn variations into rulers, and noise into thermometers. They learn from patience. As the instruments keep to their vigil, the atlas gains scale bars and contour lines. A prow defined by draping takes shape with confidence. Pinched flanks that favor outflow become visible as subtle biases in particles and in glow. A restrained wake appears where field and neutral density decide it must. The result is not a final picture. It is a reliable one, a scaffolding strong enough to carry the next set of questions and to guide the final, slower voice from the dark as it continues outward with its tin ear and faithful clock. He travels with a patience that belongs to minerals and tides. A small receiver drinks the quiet, converts it to numbers, and returns them to a planet that spins under weather and war. Antennas in deserts and hills lean upward and listen. In the cold between stars, a low chorus rises. It is not speech and not music, yet it carries meaning that can cross generations. A machine continues because engineers taught it how to sleep lightly and wake on time. A species continues because questions do the same. The answer that arrives is modest. Space between stars is not nothing. It carries density. It carries field. It carries the remnants of old fires moving in long reflections. A star does not extend without limit. It builds a skin from pressure and magnetic tension. That skin keeps in and lets through, never perfectly rigid, never fully relaxed. Corridors open for a moment, then fold. Shocks pass like distant thunder and make the local sea ring at a pitch that can be measured. The membrane is thin, the outside is older. The field remembers a direction that reaches across great distances, with more discipline than habit granted it. Human work makes this legible. A dish focuses a whisper from a signal no stronger than a kitchen appliance. A frequency counter reads a wobble that would vanish in any less careful hand. A team writes commands that must survive 1,000,000 kilometers for every minute of delay. Another team tends a catalogue of storms that left the star and took a year to arrive at the far edge as soft fists. Instruments on Earth count neutral particles that travel in straight lines and carry a shadow sketch of the scaffold around the bubble. Computers play at creation and destruction until a shape appears that can face the scrutiny of a sky drawn by particles and tones. The craft does not know any of this. It only obeys clocks and voltages. The people who built it know, and the people who came after them know, and that chain is part of the discovery. He bears a record made of copper and gold. On it, greetings crowd beside thunder and birdsong. The significance of the record is not that anyone will answer. It is that someone wished to be understood by a mind that may never exist. That wish points back toward the planet as much as outward toward the sky. A probe leaves home. The act of leaving changes home. Children grow in houses where a photograph on a wall shows a small craft with a white dish and a long boom. The idea that machines can cross a border that no eye can see is absorbed into folklore, geography, religion, and art. The map of meaning expands a little. That is a quiet human answer to a cosmos that rarely asks questions in words. A traveler without fuel becomes a textbook about time. Its heartbeat slows as plutonium cools. Instruments are turned off with a care that feels like ritual. A magnetometer remains because it can do its work honestly with little power. A plasma receiver remains because its clock stays faithful. Senses that once dazzled with portraits of worlds are allowed to sleep, so that one sense can keep listening to the dark. The choice says something simple. Knowledge that outlives spectacle is worth the cost. The quiet measurement of an unseen medium over years is worth more than a final photograph that would end in an instant. The medium that answers is itself a layered memory. It holds the dust of older suns ground fine by shocks and time. It carries the charge of ions and the caution of electrons as they move in step with fields they cannot see. It preserves gradients from collisions between clouds and from the slow drift of a bubble through a region with a slightly higher pressure. It is a library of faint causes. A probe samples a single aisle and learns enough to infer the plan of the building. The plan is not a single architecture. It is order laced with porosity, stiffness softened by exchange, discipline decorated with folds. The great detail is that such a plan can be read at all by a machine the size of a small car that left while its makers still tuned radios with a dial. The measurements teach a humility that is also a strength. The planet that receives them learns that its star is enclosed, and that the enclosure is not a defeat. It is a way of belonging. A membrane does not erase identity. It defines it by contact. Inside a bubble, planets grew, an atmosphere formed. Chemistry took risks, and minds tried to name the sky. Outside, particles wander from long-dead furnaces and find their way into new clouds, where gravity gathers them again. The contact between inside and outside is not a wall, it is a translator. It edits the reign of high-energy travelers so that a world can keep water and carbon in play without too much interruption. It admits news from far away and protects against noise. He carries no opinion about these uses. He only compares counts. Yet the consequence of his comparisons reaches into domains that his builders valued before they could prove them. If a frontier can be crossed, then maps can be anchored in measurement rather than in myth. If a membrane is thin, then exchange rather than isolation becomes the model for how systems survive. If a field is coherent on large scales, then motion through the galaxy acquires a grammar, and long journeys can be forecast with more than hope. The craft returns numbers. The numbers alter metaphors. The metaphors guide choices that do not look like science at all, until one remembers where the change began. The last electricity will go into hearing. When heaters must be turned down and one sensor after another goes quiet, the final whisper will still be fields and plasma tones. A tiny current in a long antenna will turn into a spike on a chart that says there are this many electrons in this parcel of space today. The spike will travel through the dark and then through the thin air above deserts and then along cables into rooms where a few people will know what it is. Those people will read the spike and write a paragraph with the words density and frequency and uncertainty, and someone else will turn that paragraph into a sentence that a child can understand. The chain from oscillating electrons to a human sentence is fragile and real. It is not a grand answer. It is the only kind that tends to last. There will be no arrival in the usual sense. There will be motion in a straight line that becomes a curve when measured in the frame of a galaxy. There will be a fading of contact until the machine is mute. The mute traveler will still exist. It will carry the record and the scars of radiation and the slow dusting of micro-impacts. It will act as nothing acts. It will go on. That going on is what the makers expected from it and from themselves. In a time when news arrives loud and vanishes quickly, the endurance of a small tank of power, feeding a small set of instruments to answer a small set of patient questions, feels like a form of courage. The answer to what was found beyond the system of planets is not a set of names for new things. It is a recognition of context. The system sits inside a bubble whose boundary can be weighed. The space around that bubble has properties that minds can measure with tools that fit on a truck. Those properties connect to the larger pattern of a galaxy that keeps records in field and dust. The record can be read. The reading takes decades. The scale of the reading matches the dignity of the subject. In that alignment lies the quiet human answer. The species that built the listener is able to wait, to reduce noise, to merge results, to change models without shame, and to say what is there without demanding that it be glamorous. A simple craft is not a mirror in a literal sense. It reflects by provoking care. It calls forth methods that are careful and speech that is clear. It sits in a darkness that is full of slope and thread and tone, and it points out that even very thin realities can carry the weight of a star's weather. A planet learns that it lives inside a membrane that is thin and faithful. The lesson is not about conquest. It is about understanding enough to belong without terror. That is the deepest discovery available to a visitor that cannot turn around and must trust the patience of those who listen. Night holds him as if holding a thought. The dish faces a darkness that has no walls and still feels like a room. Inside that room, electrons keep each other company and vibrate when pressed. A tone rises. A ledger grows. A planet waits and reads. He does not know summer or the smell of rain. He knows voltage and the discipline of a clock. He carries a record that remembers water, birds, and greetings spoken into a microphone. The grooves are asleep in a cold that preserves them longer than any library. If a hand never touches them, they still count as an offering. He is beyond weather that eyes can see. Snow does not fall there. Wind exists as pressure and field. The sea is a web that does not sparkle. It hums. He listens and repeats what he hears. That modest act is large enough to hold the pride of a species and the humility that follows real measurement. He will fade. The last tone will be small. The carrier will thin to a filament through which meaning can barely pass. Then the cable will be empty. The silence will not be a failure. It will be a completed sentence. The machines on the ground will keep their paint until it peels. The rooms will be cleaned. The files will remain. Somewhere in the long night, a traveller will go on, unremarked and whole. Starlight will pass its metal and continue. Dust will touch and let go. Centuries will shorten to moments in the life of a galaxy that folds and unfolds its arms without hurry. A record with thunder and laughter will ride the quiet for as long as silence agrees to carry it. In that image rests a promise that needs no witness. Leaving is real. Listening is enough. The place beyond the planets is not empty. The answer to why one should care is simple. A mind can reach that far and return with truth. The distance then belongs to everyone,